Ask them which topic they like in school. It's HCF. Do you know HCF? LCM.
LCM सब पता है आपको?
HCF, LCM.
1, 2, 3 नंबर पता है?
Talk in English. Oh, super.
Version of English.
What is 2 4 za?
2 4 za
2 4 za 4.
2 गुना 4 कितना होगा?
2 गुना
2 गुना 4. हाँ, 2 गुना 4 8. Super.
2 into 4 is 8.
आपका नाम क्या है?
मोहम्मद रतीशा।
मोहम्मद रतीशा।
मोहम्मद जी।
इंडिया?
हाँ, यतिराज।
अभी आपके पास माइक नहीं है। माइक अभी अगले बार जब आएंगे ना तो हम गणित के बारे में विस्तार से बात करने की कोशिश करेंगे, ठीक है?
You heard of such a thing that a problem can have more than one solution in mathematics?
Now I am starting to think, sir.
Yeah, there was a girl who was traveling to her grandparents' home in a bus, and she observed that her seat number in front of her, it had got number 22. What would have been her seat number?
When we think of mathematics, mathematics of what we study like sin theta, cos theta, trigonometry, algebra, all these things are not used in our day-to-day life. Why should we study mathematics?
Preferably a rural school, I would say, and give one problem like 12 plus 18 to a student. I bet there would be one kid who writes the answer for this question 12 plus 18 as 2 plus 8 is 10, 1 plus 1 is 2, 210 with a space between 2 and 10. For him it is right. This is a problem of algorithmic teaching. What do you mean by highest common factor?
Sir, when there are two numbers and you have so many...
You have done a very good homework, yes.
Budget of the government should be increased for education, sir.
There are 2 trains. One comes to Mysore station every 4 days. One comes to the Mysore station once in 7 days. Today both have come to the Mysore station. Say one goes to Delhi, another goes to Jaipur. Say both of them go to Hyderabad. I want to go to Hyderabad. After how many days they will arrive together in Mysore? So
in the multiples of 7, sir?
You are looking... So excellent. I was not satisfied by the way the numbers were defined. Number of the form a by b, that means the number already existed somewhere. So I couldn't digest this definition. That means there are numbers, there are pool of numbers where I am picking these rational numbers from, which is of the form a by b, and there are also numbers which are not of the form a by b. What is this? Where do they lie? Where do these numbers are? And then I say these two numbers clubbed together, they are real numbers. And they said the numbers which are not real are complex numbers. So I got this fundamental question: what is a number? So earlier they said number which is not rational, it should have been irrational.
Yes.
Now they say number which is not real, it is also not rational. So why it is not irrational? Why it should be complex?
And it is okay to have doubts?
Yeah, it is okay to have doubts for so long. And somehow one or the other day that those doubts get cleared. Like they are using number to define rational number. Then what is a number in general? Such a stage where you stop going further beyond, where you take for granted those statements, they're called axioms. For example, you would have used this statement to prove this. You would have used this to prove this. Use this to prove this. Now you are proving this using some other statement. How do you know that this statement would not have been proved using this? Opens up this beautiful gateway of thought process that truth is relative.
Okay.
The last fifth postulate of Euclid was something very hard for many of the mathematicians of that time to digest. You have a straight line. There is a point here. How many straight lines you can draw through this point which are parallel to this?
Only one line.
Only one.
Yeah.
Correct. Excellent. Only one.
So after that approach, you changed your approach of looking at truth in your life too, sir?
Miss, we don't tell these kinds of stories in classrooms. Why such kinds of stories are missing inside mathematics classroom? Yeah, it is full of rigid rules, rigid numbers.
So we don't think of even stories exist in mathematics. 52 is even because it has 2.
It has 2.
It is
so there is a see. This
2
is
the factor of that number.
Excellent. Oh, that's beautiful. That's beautiful. That's beautiful. Who is a factor of that?
Yes,
number? You have bottles on one side. Some number of bottles. I don't know how many. You have caps on the other side. You want to close the lid. Say without counting, you should tell me whether the number of bottles and caps are same or not. Are natural numbers more in number or even numbers more in number? So
I am looking good, sir. The wonder of Devaraja market.
This way, if you pair numbers or pair objects on both sides without leaving anything on either side, they must be equal in number. Caps, here the bottles. Natural numbers, even numbers. If I ask you, odd numbers are equal, numbers are more or natural numbers are more, what will be your answer?
So both are in same number?
Both should be in the same number. Now, for odd numbers on one side, natural numbers on the other side. 1 to 1, 2 to 3, one more, 3 to 5.
5.
Right? So in this way, you can exhaust all the natural numbers by pairing them with odd numbers.
By being with you, I am becoming brilliant, sir.
This is an illusion.
This is not Maya, sir.
Yes, this is not my.
Because this is a different axiomatic system, sir.
Yes. Oh, super. So you need to get married soon.
No, sir.
So shall I
That
look
is
for
Maya,
any-
sir. That is really Maya, sir.
Shall I look for any
Other market, sir? Other
any girl?
Sir, in market, we only find fruits, sir.
Okay.
No girls, sir.
Christian system. The students of mathematics or the students of science, strict rule that they should not have any girlfriends.
Fantastic, sir.
Why?
Yes, sir. So we are inside the market because the rain is coming out. In the out.
Yeah,
My English
now
is very
if-
beautiful.
Yeah. Introduction to mathematical philosophy. Number 1 is defined as a set.
See what are natural and irrational. Irrational are those which are in the root form.
Time being, let us stick on to this, right? Okay. So because the definition doesn't matter to us for time being. So we got to know of irrational and rational numbers, right? So the question was, are irrational numbers more in number or rational? That's like pi. Pi is irrational. It is a constant. It is the ratio of the diameter of the circle. Ratio of the circumference to the diameter.
Circumference of the circle is equal to 2 pi r.
Right. Now the question is, real numbers and irrational numbers have they got same are they
Real and irrational.
Irrational.
They should be same.
Yeah, that should be same. But you did a good guess. But it takes a lot of efforts
And
to answer
courage.
that question. Yes.
So what is this?
The
is my
answer is
homework,
yes, correct. The answer is correct. So
Okay.
reals and irrational numbers, they are both equal in. And I remember that last time you told reals are more in number. And this time you have made a right
No,
guess.
this is my
Because
first
they're
video in
only-
English, and I have not done any video previously. And these
No, last
concepts are
time
very
when we
much
met-
new to me,
Oh,
and
okay.
I don't know anything about these things. Sir is a very beautiful person, but he's lying in this thing. But I am very,
no.
very,
You can cut this,
very
you can edit
dumbest
this.
person in the mathematics arena, and I know I don't know anything in
Okay,
mathematics.
you can edit this and you can cut it off. Okay.
No. This is the reality, sir. This is the axiomatic system of Maya, and everything is real in this axiomatic system. So this is existing. Oh, so there
That is
comes
an
the
idea.
relevance of Descartes.
How does not exist? Okay.
Yes.
Yes.
He is establishing analysis.
Yeah, it's still very. You rightly pointed it out. For me, it is. It brings into me. It makes me think more about existence and inexistence.
This is the world famous Devaraja market.
Jai.
So this is Mysore Malik.
Axiomatic system. Anything, any regarding numbers can be proved from their axiom. And he says if you solve this in 3 months, you can go for mathematics. Else you do not go for mathematics. Goes and sits for months together, 3. He'll not get the answer. Nobody has got the answer. This big giant himself has not got the answer. The truth changes as you change your system. And there will be some statements which cannot be either true, which can neither be true or false. See, what we are speaking completely is from the point of view of bivalent logic. Complaint about mathematics, that mathematics is so much of axiomatized. So real life experience simply says God exists, but mathematics asks me to prove it. I like this way of teaching, that you have a goal. It may be a problem. We are trying to address that problem. To address that problem, we are trying to learn all these things. And there comes sin theta, cos theta, everything. So there should be a problem, bigger problem. Only the main challenge for the teacher is to make students understand that problem. If I understand that problem, I will now have a cause for studying this.
It is a beautiful coincidence that we started this vlog too with the same Brahma Sutra with which you started your thesis.
Yes.
तो ब्रह्म
I
जिज्ञासा.
didn't, but I think everybody is capable of constructing knowledge of the concepts in mathematics.
So in our society, there was always welcoming nature of
Suppose you have this,
accepting the Charvaka speaking in front of the Shankara Sadvaita Pitha. That is, contrasting thoughts have always existed in our society from the very ancient times.
Yes.
So we'll just accommodate these two, sir.
So you are just accommodating.
Yeah.
You're just accommodating.
Because the other thought is also just accommodating the other thing.
Oh, right. We are co-living.
Yeah.
So that is again something very beautiful. Athato Brahma Jignasa. There are 2 words in the beginning, right? Atha, ataha. Means then, therefore. An inquiry into the Brahman. Why then? Why therefore? And there itself, the interpretation of Shankara, Ramanuja, and Madhva, they all three get separated.
So in this world famous beautiful Devaraja market of Mysuru, I think for today we'll end the conversation of exploring mathematics, the Jignasa of Ganita, Atato Ganita Jignasa. So
The
we are
market is too
in the world famous Devaraja market. You might be thinking this is not so world famous. It might happen in the future.
world famous.
Yes. Because now we are here, we'll make it world famous. Today with me is YATHIRAJ sir, who is a beautiful soul, who is very much interested in mathematics, and we are going to do a vlog which is regarding mathematics amid the chaos of market. So we'll be exploring the concepts of mathematics,
Not related to market.
not related to market, but very much related to life and the very existence of mathematics itself.
But in market.
Yeah, but in market.
Only to a limited sense within the sphere of my understanding.
Absolutely. Yeah, sir.
Yes. So last time when we met, I had given you a homework. Could you?
Sir, but this is a new vlog which is in English, and I have forgotten all the homework, sir, that
Yes,
you have
yes,
given
yes.
me
Yes,
in
yes,
Kannada language.
Yeah.
So I think we'll start afresh again.
Definitely. So I was.
How were you introduced to mathematics? Because so many people hate mathematics, or you can say they have an aversion towards that subject. I don't know, because of the culture in which they grow, or they might just not love that subject itself from the very beginning of their lives. But how did you get into contact with that very subject, which so many people just don't like?
That subject. Yes.
And you also went on to make PhD in that subject. Oh.
But still, I don't call myself doctor. Okay. So,
Yeah, Dr. YATHIRAJ sir is with us.
So if you ask me what is your name, I tell YATHIRAJ only. No. So
But
it's
your doctorate is in the subject of
number theory.
Number theory of
Broadly number theory, and specifically the works of Srinivas Ramanujan.
Okay.
And ironically, see, let me start from here itself. Ironically, Srinivas Ramanujan is known to be the famous mathematician, one of the greatest mathematicians India has produced to the world.
Yeah, absolutely.
But if I ask you, can you explain me some of his mathematics?
I just completely failed to even think of any works of Srinivas Ramanujan.
So we have only few stories on his mathematical ability when he was a child. But when it comes to his mathematics, no, it is totally too specialized, which most of us cannot follow without a formal study of mathematics. But still, we know that Srinivas Ramanujan is the greatest mathematician that India has produced to the world. Mathematics, of course, it requires compared to any other, or maybe just like other subjects, mathematics is a little bit abstract, too abstract. Right? You mentioned it correctly. You said that many of the people, they hate mathematics from the beginning of their life.
Absolutely.
What do you mean by beginning of their life?
Whenever they are introduced to any subject in their life,
that's their beginning.
Yeah.
So you mean to say that most of the students or most of the children hate mathematics from class 1 itself?
Might be.
And,
The culture starts from there itself, sir.
Oh, so
This is mathematics. This is the very difficult subject. You have to learn. They infuse that fear of mathematics from the very beginning itself.
From the very beginning itself.
Yeah.
So do you agree that there are also people who love mathematics?
Absolutely, but
There are also people
very
who are-
minority of people.
Okay, very less number of people who are capable of understanding these abstractions, just like Srinivas Ramanujan. Not to that great extent, but there are people who, like me, to a little extent, they can follow these kinds of abstractions, right? And there are also such kinds of people. But as you say, majority of the people, they do not like mathematics from their childhood, mainly because, of course, mathematics is a compulsory subject which is taught from nowadays pre-KG.
Oh.
So from pre-KG itself, they teach numbers, and I'm very astonished to see that my son, who is going to LKG, has got 10 books.
Oh.
He's got
Regarding
10
mathematics
books.
or all the subjects?
No, all the subjects. He's got 10
fantastic.
books. Now, of these 10 books, there are 2 or 3 books where he has to write numbers from 1 to 100 in LKG itself.
Oh.
So they're expecting that, the expectation is that the child studying in LKG is to have the knowledge of numbers from 1 to 100.
Mhm.
The same is the problem with language. What I feel is, the child who is going to LKG, he is expected to show the proficiency of writing
Mhm.
alphabet from A to Z, from A to La, so in Kannada, and also few words. Now, the problem, what I feel is, we are focusing more on this writing and algorithmic part of subject.
The subject.
For example, in mathematics, we mainly are into focusing on doing the things as per the standard procedures. What I say, algorithmic way of doing the things. Have you ever heard of such things in mathematics, like there may be questions for which there may be more than one answer?
When I was
There
in
may be-
PUC, yes,
yeah.
when I was in PUC, I met Sri Anand Kumarji, who is famous for Super 30
Yeah.
IIT program.
Yeah.
He first time explained me about completely, answering questions in completely different dimensions, 4 to 5
Right.
different dimensions,
Right.
approaching the same problem.
Right.
So that was the first time in my
Right.
PUC that I got to know that every problem can be solved in multiple methods.
Yeah, that's one good observation, that a problem can be solved in multiple ways. But have you heard of such a thing, that a problem can have more than one solution in mathematics?
Yeah, now I am starting to think so.
Yeah. So these kinds of open-ended questions, so-called, they are prevented in mathematics. The thing, the social impression on mathematics is that it is a subject where a question has got exactly one correct answer, perfect answer. That is why anybody can score 100 out of 100 in mathematics. So this is the impression that the society is having on mathematics, which is totally wrong, completely wrong. I say we should discard it. No, it should be a little bit opened. It should be made opened. I mean, it should be opened a little bit. Like, for example, suppose yesterday I was reading some article, a very very nice article, which was an experience of a teacher who had dealt with such kind of open-ended questions in the classroom, which allows students to think in multiple ways, also allows them to articulate their thoughts, and also makes them think that mathematics is not something like a subject wherein there is only one particular correct solution which we should arrive at for a given question. There may be multiple solutions. Like,
They
for
can do
example,
anything and prove LHS is equal to RHS.
Need not be LHS is equal to RHS, or they may come to see, if I ask you a question,
Yes, sir.
how many people are sitting here, I just count and something. This is another conception. What I am telling is, hence proved LHS is equal to RHS. These are some of the kind of taboo
Mythical
concepts
stories that
associated with mathematics.
In the society, people are associated
Yeah.
with such kind of
impressions,
stories, beautiful
impressions,
stories of mathematics.
Yeah, such beautiful stories of mathematics. So the article that I was reading was something very impressive. Before going to what made me get attracted towards mathematics, let me just try to share that article, which was which was a good one. So the teacher poses one problem, simple problem to the students. There was a girl who was traveling to her grandparents' home in a bus, and she observed that her seat number, the seat in front of her, it had got number 22. What would have been her seat number then? So this is the question, very simple question.
Yeah.
What could be her seat number?
You are asking a question, sir?
Yeah, I'm asking the question now to you. So the seat in front of her had the number 22.
Yes.
What would be her seat?
That row has 3 seats, sir. In each row.
Very nice. So you're now asking questions. This is called open-ended questions.
I can enter into mathematics at this age also, no, sir? Yes, sir.
So you must pose. If you pose these kinds of questions, that leads to some kind of conversation, dialogue sharing in the classroom, and that opens up multiple arena.
Yes, sir.
Of thoughts.
Of thinking about mathematics itself.
Thinking
starts
about
from
mathematics itself. Say, for example, one student may argue that her seat number should be 23 because the number that comes after 22 is 23. It might be true.
Might be.
If there is only one single column of seats.
Yes, yes.
So after 22, 23 comes. But that's not the usual
scenario
of
societal buses of India.
Right. Yes. So there'll be in for example in Kerala there'll be two
state transport department changes buses.
Yeah, in Karnataka there'll be 2-3. So in some places there'll be single seat in the front,
yes, sir.
And then 2-3 starts, right? So based on the kind of arrangement you make for these seats, the number changes, right? The answer can be anything.
Yes, yes, sir.
Need not be 23 itself, or need not be 26 or 27. So what if somebody numbers the seats from the last 1, 2, 3, 4, 5, 6?
Number again changes.
Number again changes. So if you leave all these things for the students to think inside the classroom, then of course mathematics is not just a single question, single answer subject.
Yeah.
Of course, there are questions they've got only particular exactly one one answer for that question. You cannot say 2 plus 3 is it can be 6 or it can be 7. It must be 5 itself. 2 plus 3 is 5 itself. But what I say is, from the very beginning, if you focus only on this algorithmic part of adding 18 plus 12, writing the numbers one below the other, and starting the addition from units place, carry over. If you do all these things, algorithmic, if you focus on these things, the moment they come to first or second standard, I think they would lose one of the very important skills in mathematics, that when to apply which operation. What is essential? Yeah, what is essential is you must be able to decide for yourself what you should do in a given scenario. What would be the optimal operation? What would be the optimal choice for you in a given scenario? That's the main skill that one should acquire, right? Say for example, if you go to market, if you're thinking to buy something, in your head, you should first think of how much money you should keep in your pocket, right? So you should estimate. For estimating, what you should do. You should have such kinds of skills instead of having the skill of adding numbers column wise, adding numbers row wise, carrying over. I'm not saying they're not essential. They're not the only essential things. Right?
The other conception is too, when we think of mathematics, mathematics of what we study, like sin theta, cos theta, trigonometry, algebra, all these things are not used in our day-to-day life. Why should we study mathematics?
That is one more thing. Yeah. I agree. That is utility or application part of what
the subject of mathematics.
Yeah, right. So we shall discuss about that. We shall discuss about that as we move on. Right. So as I was telling the other day, you just go to a school, go to any school, preferably a rural school, I would say, and give one problem like 12 plus 18 to a student. I bet, or I can say with 100% surety that there would be one kid who writes the answer for this question, 12 plus 18 as 2 plus 8 is 10, 1 plus 1 is 2, 210, with a space between 2 and 10. Right? So there would be at least one kid which writes the answer in this question.
Yes.
For him it is right. This is a problem of algorithmic teaching. This is a problem of burdening the students with algorithms. So
what is algorithmic teaching, sir?
In a sense, you should stick on to some procedure to solve the given problem. You do so and so and so and so to arrive at the answer. That's it.
That is algorithmic teaching.
Yeah. I mean, I'm just naming it for my convenience.
Okay. That means we have to follow a particular procedural way of procedures.
Yeah, it is focusing only on the procedural part of some knowledge. So I was also telling this the other day.
In the other language, which is
Yeah, in the
my
other
mother
language.
tongue, which is Kannada, in
Yeah.
Karnataka, in Mysore, in the Devraj market,
Yeah.
the same seat where we are sitting.
I just forgot what did I tell in this span of just 2 seconds. Yeah, this one. So even in today's degree classes, I teach for degree students, BSc students, BCA students, mathematics, right? So they're these
Understanding.
BCA and BSc students,
Uh,
they have got a paper called number theory, or mathematical aptitude, right? So there they'll study this LCM, HCF, all those things again. You might have heard of LCM, HCF.
yes, sir.
Right? HCF is
Very from a very distance point of view.
right. HCF is
Highest common factor.
excellent, very good. So LCM is
Least common multiple.
excellent, very good. So all students, they tell what is HCF and what is LCM. That LCM is least common multiple and
Highest
HCF is
common
highest
factor.
common factor. And the moment I ask them, how do you find out? So you give us two numbers, sir, we'll calculate what is HCF. And then I'll ask them, what is HCF? They say highest common factor.
Yes, sir.
What do you mean by highest common factor?
Sir, when there are two numbers
Yeah,
and you have so many.
you have done a very good homework, yes. No,
Sir,
you
I
know
don't
it,
remember
you
any
know it.
conversation from the previous conversation, sir.
But you know it.
I'm
you
like
know
a
it.
white
You-
paper, sir.
Yeah, you know it. So, but
Yes, sir. But what is the
not
highest
even
common
one
factor,
student.
sir?
Not even one
For the
student.
audience. What is the highest
Yeah,
common
let me
factor?
tell.
Yes,
Not
yes,
even
sir.
one student in my class. That's the most joyful moment for me in the class.
When they
I'd
failed
be
to answer your question, sir?
Yeah, I would have gone. No, this particularly this question. I would have gone inside the class. Feeling that let me not get even one student who answers what is HCF. And I will be totally joyful when I don't get even a single student who knows this. So then I can tell some dialogues to them, some quotes to them. So that's why. So the most ridiculous part of our education is people are doing things without knowing what they are.
Making
what the
us
things
more,
are.
look so much wiser than those people in the classroom, nice? When they
Which
don't
one?
answer.
Which one?
When they don't answer and we answer, na? The same question. It makes us look very much wise in the middle of those students in the classroom.
For a student.
For a teacher who is asking
For
the
a-
questions.
For a teacher.
For a teacher who is asking the questions, and when they see that the students are incapable of answering any question, and they answer the question, the teacher himself answers the question, na? Then they feel very much wise amid the
Oh no!
crowd of
I
students.
don't feel that. I don't feel that because you see, I feel joyful mainly because of the fact that I can tell them
Yeah.
how ridiculous this education system is.
Absolutely.
That's the reason. That's the reason I feel very joyful. So they are doing things without knowing what it is. So simply they are altering. They are doing algorithms, but finally they have got an answer and they do not know how to interpret that answer. So this is one of the most ridiculous thing happening in the education, right? So one more thing. So I asked them to recite tables. Beautifully they recite the tables. 2 1s are 2 2 2s are 4. So we had talked this also in the previous 2 3s are
I forgot,
6,
sir. Everything.
2. And then I asked them to write what they are reciting. So they write 2 into 2 4. No.
sir.
You have to write what you are reciting. So they don't understand. So then I write on the board 2 1 za 2. I write ONESA.
Correct, sir.
Then they see that and somebody, yes sir, you are right, what you have written is right. And somebody says, no sir, in place of yes you should have got J, 2 1 ja 2.
Yeah.
Oh, it sounds 1 ja.
Yes,
No,
yes.
it should be Z, 2 1 za.
Phonetics.
Yeah, so they're not getting, they know what it is, but still they know the answer, but they still don't know what they're reciting. And then I have to, once again tell them how ridiculous our education system is. Right? So these are all
So
some
what is it,
examples
sir? What is exactly 2 1
it is simply 2 1 2 2s or 4,
Oh,
2 3s or 6, 2 4s or 11. So simply, so we have made it 2 1s 2 2s.
I remembered it back, sir. I remembered it back, sir.
Yeah. So when I speak of all these things, and then whenever sometimes later I once again write 2 1s 2. All the class laughs, right? So they know it now. So that this is not the thing. So this is the most, and one of the most beautiful things is that I have read some research articles on how students learn algorithms, and there some of the researchers, they propose that children have the capability to invent the strategies, invent the strategies of addition. They have got the ability to invent the strategies of subtraction also. Right? So somehow we are not believing
ability
students
to invent the methods
invent the
of-
strategies. They can invent this. So, see, if I teach you to add two numbers, writing one below the other, 12 plus 18, whose strategy is it? It's not my strategy. Sorry, it's not your strategy. Whose strategy is it? It's my strategy. I'm teaching it to you. But where is your strategy for solving this problem? The very essence, the very purpose of teaching mathematics or teaching any subject is to equip the students or develop the students the ability to solve problems on their own, right? So if I'm giving you the strategy, then what is the strategy? What is your strategy? But the research says students have the capability or ability to invent the strategies. And we are not believing the students. We believe that they are the receivers of knowledge, and we are the Jnana givers. So they are blank slates.
Sir, but
There
don't
comes
you
a
think
problem.
that a teacher also has the responsibility of teaching the strategies to a student?
Of course,
Of how to tackle
definitely
the questions?
not teaching. You just discuss strategies. If it is feasible for him, if it is easy for him, or if he can accommodate that within his conceptual framework, then he would buy it. If not, he'll not buy it. He'll reject it. What I am telling is there should be a scope inside the classroom for discussion and for the evolution of strategies. There should be a scope inside the classroom. The
Where we can
moment
discuss
students,
freely of their strategies too.
of their strategies too, they should articulate whether it is right or wrong. So there's one very beautiful quote in pedagogy. Never teach a student not to do a mistake which he should not have done.
Once
Never
again, sir?
teach a student
Yes.
not to do a mistake which he should not have done. Let him do a mistake. That mistake should not have done, but let him do it. They learn from their mistakes. So mathematics is a big, rich pool of a subject where one can do mistakes very easily. Right? They'll learn from the mistakes. There should be a scope for mistakes. It's not an accurate subject in the sense that they need not be so much accurate always. This applies to any subject, not just mathematics. But mathematics is a subject where they have got plenty of opportunities to do mistakes. Allow them. Learn from the mistakes.
And they are not going to lose any resources for committing a mistake. Like in chemistry
Definitely.
labs, you are going to lose some chemicals.
Some chemical.
Yeah.
Well, if you mix this with some other mistakenly wrong something, then
You'll get punishment?
that happens. And in fact, I recommend that you do that also.
Sir, the teacher will not give the chemicals the next time, sir.
Yeah, that's one problem. Again, another problem.
I think the
It's a
budget
mistake.
of
So
the government should be increased for education, sir.
See, you should do trial and error at some
The
to some
institution
extent.
should allow the students to do error.
within the constraint of their budget, I think they should allow.
Sir, when you put a constraint on the budget, na, sir, they will drag you to the least common possible thing.
Yeah, this might be out of our
Scope of discussion.
scope of our discussion or scope of our what do you call? It's not within our
Limits
limits. So we
of the society.
not within the limits of. So suppose you're the principal of a college. What would you do? So it would be quite difficult for you in such a scenario. But within the constraint of your resources, within that constraint, of course, there will be always a constraint. Within that constraint, how well you can make the students.
I remember this story of Sri Narayan Murthy ji, who was also a student of the very same institution of Sharda Vilas College in Mysuru, where you teach now. That story was in a program. where he discussed about this topic of the chemistry teacher he had during his school days, who did not allow the common table salt to be used in the maximum quantity which the student required. He asked for, because that salt belonged to the college.
Okay.
He told that student to take the table salt from your school, from your house, or you come to my house. I will give you the table salt, according to your requirement or your want. But this property belongs to the school, and we should not waste the chemical that we have.
Was this a complaint of?
Naranmurthy ji? No, he learned his life lesson from there.
Okay.
We should not waste the institutional resources.
Fine. So that's what I said. Within the constraint of your resources, we must be able to think how well we can, engage the teaching learning process, right? So there'll always be a constraint. So that cannot be avoided. We are speaking of
Highest common factor.
Yeah, highest common factor and least common multiple.
Least common multiple.
So you see, the moment, in fact, what a big complaint I have in schools is that the moment the students come to school, they start reciting tables and numbers.
For the mathematics is tables.
I'm not generalizing.
Numbers.
I'm not generalizing. There are schools who are doing very well. I know them personally. So, but most of the cases, the way we were brought up, the way you were brought up, the way most of the students are being brought up right now is this way of fixed, rigid way of algorithmic teaching. Teach only them rules. Teach only them how to take LCM. Teach only them how to take HCF. Don't teach only them how to add two fractions. Don't allow for any discussions or conversations inside the classroom. This is how it is being it's happening in mathematics classrooms. Now coming to LCM, say suppose think that this is one hypothetical problem that I am posing to you, right? So there are two trains. One comes to the Mysore station for every 4 days. So if it comes now, after 4 days it comes to Mysore station. So one comes to the Mysore station once in 7 days, right? If it comes now, it comes after 7 days, 14 days, like that. Today both have come to the Mysore station. Say one goes to Delhi, another goes to Jaipur. Say both of them go to Hyderabad. I want to go to Hyderabad. My sister stays in Hyderabad, so right. So the maximum possibility of getting a seat for me is that when both the trains are in the Mysore station. On that day I can have the probability of getting the seat for me is more. So that's why I look for the day when both the trains arrive at Mysore. Now suppose today they have arrived, right? After how many days they will arrive together in Mysore station? one train comes once in 4 days, another comes in once in 7 days.
Yeah.
After how many days both be back at Mysore station?
4, 5, 6, 7.
So
in the multiples of 7, sir?
You are looking so excellent. You're looking for multiples of 7.
Yes.
At the same time, you'd be looking for multiples of 4.
Yes, sir.
Where do they coincide? Right? They coincide at 28. Correct? There is a least common multiple of both of them. Common multiple, least. That's it. Least of the common multiples of both 7 and 4.
So 4 has multiple. 4 ones are 4 is a multiple.
Yeah, 4 twos are 8 is a multiple. 8
is a multiple of 4.
4. 12 is a multiple of 4. 16 is a multiple of 4.
Okay.
Similarly, you would be looking at the multiples of 7. When do they meet both? They meet at 28.
Okay, 4 7s are 28, 7 4s are 28.
And no other option, no other common multiples for them. See, 7, 14 is not a multiple of 4. 21, no, 28. 28 is a multiple of 4. Right? So you are searching for the multiples of 7 and 4 and you are looking for least among them. So that is least common multiple simply.
So 28 doubles when it is multiplied twice, that is 57.
Yeah, 56.
56. They will meet again.
No, they will.
But the least is 28.
28, yeah. Correct. The least is 28.
Uh-huh.
So another
So
common
that might
multiple
be
is
meeting,
56. Yeah, 56.
so many times.
And then again you add 28 to it, that would be another one.
Mm-hmm.
So multiples of 28 would be the common points for both of them, right? So
The least common multiple between both tables
common of
is
both
28.
28, that's it.
Yes.
So simply students are unable to articulate this. They know the phrase is just before them, least common multiple. Least among the common multiples of those two, they are unable to articulate this. So of course I don't know the reason. Maybe some of them might be shy because if they are mistaken, if they're wrong, then they might have felt that others would laugh at them. I don't know the reason, but students, they are unable to
They can answer me. They can answer like me, sir. No, sir?
Yeah.
Like a very
So
beautiful
like
student.
now, what is the highest common factor?
Yes, sir. So they are common, but they are highest factors.
Highest of the common factors, simply. Like for example, if you want to find there are multiple. Now by this definition itself, you don't need to follow the high school algorithm for finding the HCF. Can you just tell me what is the highest common factor of 12 and 16? You just need to list the common factors and pick the highest one. What are the factors of 12?
12 on 12, 12 to the 20.
Factors. No, you should look for
Factors 4 on
factors.
4 3 to 12.
Yeah,
2 6
so
12.
you should look for the numbers which divide 12. Yes, correctly. 1,
2,
2,
4,
3,
3 and
4,
4, 6,
6, and 12.
12.
Correct. And then you should look for the factors of 16 also. 1,
2.
4, 2, 4, 8, 16. The common among them is 1, 2, and 4.
Factor is that number which divides the number.
Without leaving any reminder.
Mm-hmm.
In the sense, only we are allowing integer divisions. We are not allowing decimals anywhere here in this.
Integers and decimals.
No, we are not allowing any decimals in this process of division.
Decimals are those numbers which have dots.
For time being, you can simply
Consider
think like that. There
those
is one more
decimals, from the very rough perspective of the society.
rough perspective. Yes, you can.
Yes, sir.
So, in this way, highest common factor is highest among the common factors. So that is HCF for you, right? So
what is the answer for that question, sir?
4, right? Common
12 and
factors
16, na?
Common factors are 1, 2, and 4. Highest among them is 4. So you asked me how did I get attracted to mathematics?
Yes, sir.
It was mainly my father was working in bank. These bank guys are they themselves are calculators.
Yeah.
So they calculate simple interests, percentages. They don't need any calculator. They calculate it in their brain, their mind. They would be having their own strategies. They would be evolving the strategies, simple strategies. So today he would be solving this problem using some strategy. He would be on a constant thinking process of refining the strategy for tomorrow. So in this way, my father had taught me more than one strategy for adding numbers, for multiplying numbers, only in your brain. So he used to give me some problems. I should not. His condition was that I should not use any pencil, paper or pencil. I should try to add the numbers in mind. Initially, I used to add numbers by thinking them that they would have written one below the other, and then adding the units, then taking carry over, and then doing all those things in mind. And then immediately he taught me one simple process of adding two numbers. And then again, as I said, there would be evolution of strategies for him. Next day he would teach me some different strategy. So this in fact attracted me towards numbers. In fact, I used to multiply 2 by 2 digit when I was in class 1 or 2, I don't know, because of his strategies, very good strategies. Of course, that was good to me also then, because I was amazed at the way they were. Very simple strategy. So, like for example, to add 18 and 12, the first simple strategy that he taught me was to take out this 8 and take out this 2, and add this 10, and then add these 2, club all of them together and you will get the answer. This was first simple strategy that he taught me. And then for multiplying two numbers, the same process he followed. So you take 18, 10 plus 8 you make, and 10 plus 2 you make, and some kind of multiplications. And so this was this was an amazing kind of stuff for me that attracted me towards numbers.
I remember the videos of Shakuntala Devi ji,
Okay.
who was called as a human computer.
Yeah.
In one of the videos, she just shuts down some person who was trying to speak in between the calculation
Yeah.
in her mind.
That would,
I'm just calculating.
disturb her.
Don't speak.
Yeah.
So we think that it is extraordinary to arrive at a solution, but it is just a simple process which are happening in our mind at a very faster pace. That is
Yeah,
bringing
for
us,
some people, yeah,
Huh.
for some people, yeah, for some people. And the most fascinating thing was that he used to ask me the question.
Who, father.
My father used to ask me the question whenever I gave the answer to him. He used to ask me the question, how did you do it? That is the most fascinating. Somebody asks you that question, that would make you happy, in fact, right? If you would have given some answer, and your teacher asks you, how did you do it, man? Explaining that part, that answer itself would be, very joyful moment for us, right? So that was one of the most interesting aspects in my life. So he used to ask me, how did you do it? Then I used to explain him, oh, I did it so and so and so. Oh, good. And then he would you should have done it like this, you see. So this was the thing. And then he used to take me to his bank on every holidays. I used to go there, and there was this typewriter, all those things, and there was carom, there was chess, everything was available in his bank. And there I got to use the calculator for the first time. They had calculators, and then I got to know I got to know how to use calculators. That made again the numbers more attractive to me. Use of calculators in early childhood. So this was how I got attracted to numbers. In essence, allowing for evolving strategies, or giving chance for opening rooms for multiple strategies, and allowing you to articulate your answer, right? So this was how my father made me love numbers in the beginning. But somehow I lost touch with this love for mathematics for my high school days. Most of my middle, primary and high school days, where I simply followed this algorithmic procedure of
You developed love at which age of yours?
no, just when I was in class 1 or 2, my father used to play with me these kinds of number stuffs. And then he didn't take care of my studies. My mother used to take care of my studies. But in 10th standard, I think, my teacher, he once again, this was another good thing in my life, that he allowed me to do whatever problem I liked. So he gave me some set of books, and he allowed me to do whatever I liked. And that
Your teacher?
Yeah, my teacher. So
Mathematics teacher?
Yeah, mathematics teacher. So that helped me again develop an interest or passion towards numbers.
If you want, you can take his name also, sir.
Yeah, of course, he's Mr. Bhanu Prakash. I think he's a government school teacher now in some high school. I think in Nagmangala, somewhere in Mandya.
In Karnataka?
Yeah. But most of the times, I had some very deeper doubts. What do you call them? You cannot call them doubts, but in Kannada we say gumani. I was not satisfied by the way the numbers were defined. There is a problem to me, the way the numbers were defined. Like, for example, they defined rational number as a number of the form a by b, where they use number already.
So we just know numbers means 0, 1, 2, 3, whatever are the numbers.
Yeah.
You are saying rational numbers. That means
A number
there are
of the
categories
form-
of numbers.
Yeah. So they say a number of the form a by b. That means the number already existed somewhere. So I couldn't digest this definition. That means there are pool of numbers where I am picking these rational numbers from. which is of the form a by b. And there are also numbers which are not of the form a by b. Now, what is this? Where do they lie? Where do these numbers are? And then I say these two numbers clubbed together, they are real numbers.
Rational plus irrational.
Irrational. And when I came to pre-university, and they said the numbers which are not real are complex numbers. And that was totally, totally confusing for me, because earlier they said number which is not rational, it should have been irrational.
Yes.
Now they say number which is not real, it is also not rational. So why it is not irrational? Why it should be complex? That means there are pool of real numbers separately, complex numbers separately, and they are arbitrary. So this was a kind of total confusion for me, that nothing is properly defined or nothing is properly communicated to me in all the days of childhood. They have not properly communicated to me what a number is. Specifically,
the fundamental question of a number.
Question.
We don't
So
know
I got
what is a number.
I got this fundamental question: what is a number? So that creeped in my mind to such an extent that I used to think of this. So what is a number? What is a number? They say they are using number to define rational number. Then what is a number? Did you understand this? They are using number to define rational number. Then what is a number in general? What is that pool? And fortunately, very fortunately, I somehow, I don't know, because of all this quest, because of searching, I got one book. It's called Introduction to Mathematical Philosophy of Bertrand Russell. And that opened a fascinating world to me. That showed me a fascinating world to me. Along with that, I got one more book, what is called Essays on Theory of Numbers by Richard Dedekind. So, see, when what makes you happy, very, very much happy? What makes a person very much happy? When he feels that, when you think that whatever the doubt you have got, so many other people had also got the same doubt. So if you get to know of that thing, you'll be so much happy, right? Yes. Oh, I'm not in a wrong path. I'm in a right path.
Yeah.
That makes you very happy.
Yeah.
So the same thing Richard Dedekind had written in his book, that we have not properly defined rational or irrational numbers or real numbers. Something should be defined based on what has already been there, and not you should simply throw the definition afresh.
So he is one of the famous mathematician, and
yes.
he too was in doubt of what is numbers. What are numbers?
Yeah, I mean, he was speculating. His
expressing his thoughts. No?
Yeah, his quest was for a different objective, but he expressed the same thing, that whenever you define or introduce something, that should be done based on whatever that has been clearly defined or clearly communicated, without much doubts or much confusion. Say, for example, if you say rational number is of the form a by b you have not said anywhere. What do you mean by b? A by b, you have not defined that symbol anywhere. A by b, right? So that is too vague, vague way of defining something. So then there in the two books, I got to know that whatever I had got, the doubt was very valid one.
Yeah.
And finally I cleared.
And it is okay to have doubts?
Yeah, it is okay to have doubts for so long.
Yeah.
And somehow one or the other day that those doubts get cleared.
Yeah.
Right? So they define the natural numbers. The natural numbers, in fact, what is 1, what is 2. Now, of course, we, as I said in our last conversation, this is a totally irrelevant question for many of us. Of course, this question should not be asked. As a teacher also, I should not ask this question, what is 1, what is 2. That would be a bigger sin, adding a poison to some good food. I should not ask what is 1, what is 2. I should answer the question only if somebody gets a doubt. I had got the doubt, and so it was for me to clarify that doubt. I clarified that doubt. Right? So this would be totally irrelevant for many people. What is 1, what is 2?
Because they don't have doubt itself.
Yeah, doubt itself. But that would be, solving until it gets solved, some people would not get settled. They'd be unsettled.
Yeah.
So there I got to know the definition of natural numbers, unlike the
And
way we see.
in that quest, they might end up giving their entire lives itself.
Definitely.
For
So
that
that was the case of so many. Like I was reading a story of a monk called Sasheri. He gave up his life for completely, a so-called futile attempt during his time. Futile means useless attempt during his time. Right?
Of what?
So I'll come back to these numbers after this discussion. Like, this is another aspect of mathematics that we are now going to discuss. Okay, one of the most beautiful aspects which attracted me to a greater extent towards mathematics. The first point of attraction was a book called A Certain Ambiguity. The name itself is so beautiful. Certain Ambiguity. Anybody can read it. Right? It's a novel. It's a mathematical novel, and anybody can read it. A Certain Ambiguity. I think it is by Bal Arun. I don't know the authors, Indian authors.
Name is
so
beautiful.
It is Certain Ambiguity. So it's one of the such a good books that came to my hands, and I read it. And then immediately, I got attracted to this axiomatic way of doing things in mathematics. I didn't know till that time.
What is axiomatic way of things?
There was this axiomatic way of getting to know of what is truth, mainly. So finally, ultimately, we are searching for truth, right? Finally, we'll be looking, or will
minority section of the society is looking for that. Maybe. I might say.
Okay, maybe.
Because so many people are following the bandwagon, sir.
Yeah, I'm not telling in that sense, but see,
the ultimate goal of
if you're studying something, if you're doing some study seriously, if you're studying something seriously, of course, one thing you would be aiming at is to understand what is true, right? Try to understand what is true, what is not true. So that's the thing. So very long back in the Greeks, in fact the Egyptians, they were doing good mathematics. But the problem was there's no proper structure for there was no proper framework for validating whether our argument was circular one or non-circular one. In the sense, say, I want to prove a statement. For example, let me take a very simple statement in mathematics. You know what a triangle is. You know what an angle is. You know what are interior angles of a triangle. Sum of the interior angles of a triangle is 2 right angles. That is 180 degree. 2 right angles means 2 into
right
90
angle is 90 degree.
90 degree. 2 into 90 is 180 degree. That we all know, right? Sum of the interior angles of a triangle is
180 degree.
180 degree. How do you prove this? This thing, it's not God-given statement.
Yeah.
You need to realize it, right? So how do you realize it that it is true? You need to argue.
Yeah.
For your argument, you need some other statement. Without that statement, you cannot come to this, right? You need some other statement to come to this conclusion. And how do you know that this statement is true?
You have to assume.
Say this is my statement. Now I want to prove. Now how do you know that this statement is true? You need some other statement for this as a backing up, right? So how long you can go?
You have to stop.
Taking the help of other statements. You must stop at some stage, right? So this is one thing. So you must stop at some stage where you cannot question that statement further. You should take it for granted. If you question it, you still further move on. You cannot do it. So you must stop it. So such a stage where you stop going further beyond, where you take for granted those statements, they're called axioms. Without any necessity of proving them further. They're called axioms. Right?
We are just believing that they are existing.
We are just believing that they are true.
They are true.
We are not even believing, we are simply assigning the value of truth to them. I'm assigning the value true to them.
To that concept.
To that statement. To the statement. Simple statement. Right? So, what Euclid did was one of the beautiful things. We don't know whether Euclid existed or not. Because there are so much speculations about the existence of Euclid. So many claim that Euclid never existed.
Okay.
Because
Like
we have-
Veda Vyasa of India.
Huh?
Like Veda Vyasa.
I am it's out of syllabus for me. So I think Veda Vyasa is a Purana and Euclid is a history. You don't agree?
Now, according to you itself, Euclid is also a myth.
No, people are arguing. Some people are arguing that Euclid never existed because they have only 1 or 2 references in history about Euclid. Only 1 or 2 references. We do not know where, the place where he was from. We simply guess from some commentaries. We simply have guessed from some commentaries his time period. We don't know. But there are commentaries. There are 1 or 2 places where somebody has commented about the existence of Euclid. So therefore, we take it for granted that whether Euclid existed or not, his work, what is called Elements, it exists. It is now in our hands.
His work is Elements.
Elements. So Elements is the compilation of all his works. Right. I think it is a volume of 13 books. Totally, 13 books of Euclid, and for all these works of Euclid, Thomas L. Heath has written somewhat elaborate commentaries in his 3 volumes for all these books of Euclid, right? So he has named them Elements only, and he has written commentaries, including historical remarks, the problems in Euclid books, everything. So Thomas L. Heath has written the commentaries.
He existed, sir?
He was a 19th or 20th century mathematician.
Okay. So we
Or
could perceive him.
historical mathematician, I guess. Okay. So, right. So, let us assume that Euclid existed. Okay, he did all those things.
Elements.
One of the most beautiful thing that Euclid did was to pick up some common statements through which, by assuming them to be the axioms without questioning them, is it possible to arrive at all the results that is before him?
Okay.
All the theorems or all the statements that is before him, like Pythagoras theorem, Thales theorem. Now, is it possible for him to arrive at all this with his
So
axioms?
Thales and Pythagoras theorems were existing before Euclid itself.
Of course, those theorems were in the existence,
Okay.
and the greatness of Euclid is creating a framework wherein, as I told, he picked up some statements, some common statements, which I called axioms, and you should accept them without any questions. And using this, would it be possible to arrive at all this? So that is the greatness of Euclid. So before Euclid, nobody worried about this. They simply, this statement exists and prove this. This exists, prove this.
LHS is equal to RHS.
So you're so much
Passionate about that.
passionate about LHS.
LHS is equal to RHS.
How do you know that? Say, for example, you would have used this statement to prove this. You would have used this to prove this. Use this to prove this. Now you are proving this using some other statement. How do you know that this statement would not have been proved using this? This statement, if you are using this to prove this, but you would have proved this using this in somewhere else, this would be a circular argument.
Yes.
Right? That should be avoided. How would you avoid it? And this is the axiomatic framework to avoid such a kind of arguments. And also, this proves the limitation of a system, the limitation of a truth system. This also opens up this beautiful gateway of thought process that truth is relative. Truth is always relative. It always depends on the system where you stand in. If you are standing in this system, it has got a different axiomatic framework. If you are standing in this system, it has got something different axiomatic system. The truths may be different, right? So what Euclid did, he picked up some 5 statements which you call them as axioms, right, or postulates, like very simple statements. So that can be easily, we can take it for granted very easily. Like for example, there are 2 points, and you can draw a straight line between them. Do you need any kind of proof for this?
No.
No, you can take it for granted, right? Similarly, there's a straight line. You can extend the straight line on each of the sides. So there's a point, there is some distance, you can draw a circle, right? So these are some of the very fundamental statements that he took as axioms. The next one was, you take any 2 right angles, the angles will be same. You take anywhere, the angles will be same.
Okay.
But the last 5th postulate of Euclid was something very hard for many of the mathematicians of that time to digest. Many of the people, they thought that it is not a postulate. It's not so easily, it is not so easily seeming to be evident, self-evident. There is some scope for proving it from the other postulates, from the other axioms, or from any other statement which is somewhat little bit more self-evident from this statement. In the sense, this statement did not seem to be so much very self-evident like the others. People ran behind proving this statement. Did you understand? So they're not ready to take it as an axiom.
Yes.
They thought that no, this is not looking like an axiom. It
The
needs
first
a
was
proof.
just a point, and you were
There is no problem with that. It was so easily self-evident. But this was not self-evident.
5th postulate of Euclid.
Yeah, 5th postulate of Euclid. It is something like if there are 2 straight lines like this. If we draw one more transverse line like this, and if the angles here in this, so you have drawn a transverse line to this. So how can I say like this?
2 lines in a parallelogram fashion.
Let me. This is. So you have there are lines like this. They have drawn a transverse. So can you see angles, both the inner angles here? If some of them is less than 2 right angles,
right angle is 90 degree.
90 degree. If the sum
right
of these
angles is
angles,
180 degree.
If the sum is less than 2 right angles, they would meet at this side. The 2 lines would meet at this side. If it is more than 2 right angles, then they would meet at the opposite side.
Might be meeting at the opposite side.
Opposite side. They would meet at the opposite side.
Okay. So now.
So something like, if this is like this, more than 180 means this angle. You look at this, right? Opposite side they would meet. In the sense. So if some of the angles is more than 2 right angles, they would meet at the opposite side. As such, you yourself also feeling that this is not so self-evident, right? Do you think that this is self-evident, very self-evident?
Yes, sir. I thought. If it is lesser angle, then they would meet in the same direction. If it is more than the 2 right angles, then they would meet in the opposite direction.
Opposite side. If both of them are equal to, so sum is equal to 2 right angles, then they'll never meet. This was not so self-evident. Like you can draw you can draw a line between 2 points. It's not so self-evident. So how do you know that they'll not meet anywhere if we extend?
They might meet at some point, sir.
No, nobody knows. So this was what many of the people got doubt. So this is not so self-evident like the previous ones.
Previous 4 postulates of Euclid.
What if we could prove this from previous 4 or some else equivalent statement or some other statement which is a little bit self-evident than this? Can we replace this by some other statement which is a little bit more self-evident compared to this? So this was the thing which many people went behind. Like for example, as I told that time, Sasheri was a monk. He went behind.
He was also a mathematician.
I don't know. He was a mathematician. He liked mathematics. I don't know. Was he a mathematician or not? But he was a monk, basically. So he went behind proving this 5th postulate.
Oh. He was from Japan, sir.
I don't know where he is from. Sasheri.
His name makes me feel that he is from Japan.
No, is he a German? I don't know where he is from. Right? I don't know where he is from. Sasheri. I just know. But he died before getting to know of some beautiful truth.
Oh.
Working so madly on this, trying to prove this fifth
What was
postulate,
the truth, sir?
he died. Yeah, so the truth is, see, suppose this is one statement, fifth postulate, right? So people have gone behind proving this. While while trying to prove this, they realize that this could be equivalent to some other statement. Now, if you replace this statement by some other equivalent statement, still all the theorems before Euclid could be proved by this 5.
Okay.
This can be replaced by some equivalent statement. One equivalent statement is this: sum of the interior angles of a triangle is 2 right angles. This is equivalent to this fifth postulate.
So we don't have to disregard the contributions of Euclid like that itself. We can consider the 4 postulates. Fifth itself, we can change to some extent.
You can change. So there are these 5 postulates. So while proving this fifth postulate, some people got to know that this is same as proving this. If I prove that sum of the interior angles of a triangle is 2 right angles without using this, then I would have proved this. These 2 are equivalent. Proving this is same as proving this is same as proving. So what they did is they replaced this fifth one by this. Sum of the interior angles of a triangle is 180
degrees. Okay.
Now it is enough for me to find one more system of postulates where this can be proved without that parallel line thing. If I can do that, then so people went behind proving this sum of the interior angles of triangle is 180 degree without this fifth postulate of Euclid. And finally, one day, some guy, while in the chase of this proving the fifth postulate, he simply thought of replacing this. What would happen if I replace this with sum of the interior angles of a triangle is less than 180 degree, less than 2 right angles? What would happen? He just replaced that postulate with sum of the interior angles of a triangle less than 2 right angles or less than 180 degree. To his astonishment, the fascinating thing that emerged was that he got a system which is free of contradictions and which was consistent. It was also correct completely. All the theorems of the Euclid, there were analog theorems, analog statements, analog results in that system. Now see the essence, see the thing here. In the system of Euclid, what is the sum of the interior angles of a triangle?
180 degrees.
It is 180 degree. It is based on this axiomatic system. Now in this new system of axioms, what is the sum of the interior angles of a triangle? It is less than 180 degree. And that is not false. That is also true. So in this system, sum of the interior angles is less than 180 degree. In this system, sum of the interior angles is
180 degree.
180 degree, right? The same
there is
fashion,
absoluteness, here there is relativeness.
No, the truth is relative now. No, if I ask you what is sum of the interior angles of a triangle is, you must ask me in which system. Now you must ask me in which system. Like for example,
Euclidean system or
non-Euclidean system. So now you see how the truth changes, how the truth completely changes. So in Euclidean system, there is a statement that you have a straight line. There is a point here. How many straight lines you can draw through this point which are parallel to this?
Only one line.
Only one.
Yeah.
Correct? Excellent. Only one. But in this system, you can draw more than one. But that is true in that system. Right? This is how truth changes as you change the fundamental beliefs, fundamental axioms. This was what Euclid showed to us. Of course, there were a lot of problems in Euclid's axiomatic system because these 5 axioms were not enough to prove all the statements that Euclid had said that he had proved it. Right? So, no, Euclid had missed a lot because while proving a theorem, he made use of a kind of argument that if you take this triangle and if you put it on this triangle, you will see that those 2 are equal. But nowhere his axioms say that you can take a picture and you put it on a picture, another picture. None of his axioms allow this, right?
Okay,
none of these axioms allow
themselves were first assumptions.
Yeah.
And after making some axiomatic statements too, he was not assuming the same very axiomatic systems which he proposed.
Yeah, so he proposed one thing which
And
he had
he-
not assumed
Yeah.
before as an axiom, but he was asserting that if you take this, if you put on, but none of the axioms speak of taking this and putting on this, right? So his system is somewhat incomplete in that sense. Later on it was tried to made complete, rectified by Hilbert the 19th century, and he proposed, I think, 19, 20, I don't know, 23 or 19 axioms or 18, I don't know, some more number of axioms, and then it was somewhat more complete than what Euclid did then.
So after that approach, you changed your approach of looking at truth in your life too, sir?
Yeah, of course. The moment I read that book, that took me to axiomatic system, and then I got to know of non-Euclidean geometry. And then I got to know that truth always depends on your fundamental beliefs. First base propositions, right? Axioms. So first base axioms, fundamental axioms. As the axioms change, your views also change. I mean, your truth also changes. Truth is relative. Now, if you ask me what is truth, I don't know what is truth. And even if you ask me what is non-Euclidean geometry, or and it was I forgot the, I mean, I didn't tell the name of the guy. It was Bolyai. You see, there is one beautiful story about Bolyai. Bolyai.
Can
He's Johann Bolyai.
Bolyai spelling, sir?
Bolyai, I think.
Bolyai.
Bolyai. Johann Bolyai. I don't know how to pronounce it. I pronounce it as Johann Bolyai. His father is Wolfgang Bolyai. Right? Okay. So
Both are mathematicians.
both are mathematicians. So his father was a close friend of Gauss.
Gauss.
Charles Frederick Gauss.
Gauss. Have I heard
think,
his name in chemistry?
I think you would have heard his name in PUC,
In mathematics?
in physics, in electricity. Gauss divergence.
Okay.
Something related to divergence. Divergence of electric field. Gauss divergence theorem.
And completely very much away from science, mathematics.
Okay, so he's Gauss.
Huh.
He's a child prodigy, a very famous mathematician, Gauss, right? So this guy, Wolfgang Bolyai, the father, he warns his son not to go behind proving Euclid's fifth postulate, that he himself had tried and he had failed. The father himself had failed. And he warns his son not to go behind proving Euclid's fifth postulate. But he neglects his father's advice and he goes on trying this, and finally he arrives at this non-Euclidean geometry, where he replaces this fifth postulate by some other, and he gets a consistent system completely. Okay. So he then says, he calls his father and he says, "See, I have done this so much, such a beautiful thing in my life." And his father immediately says, "You should immediately publish this work, because violets appear at all places at all times,
Simultaneously.
The flowers grow simultaneously at all places, right? So who knows? Somebody might have discovered the same thing, might have discovered the same thing which Bolyai had discovered." So he immediately takes that and he goes to Gauss and shows him, "See, Gauss, what my son has done." And Gauss sees that and he laughs. He opens his drawer and throws this paper. So I have done this long back itself. So what this?
So why didn't he publish, sir?
I don't know, but why Gauss didn't publish, I don't know. But see, this is some story which is revolving around this all these kinds of stories. They attracted me more. They attracted me. So Gauss had done it long back before Johann Bolyai himself, and then there were so many. Bolyai got to know that so many other people were behind that. For example, Sasheri was behind that. Was doing this very madly, and there was another mathematician like Leboshevsky. So he was behind this, and then he got to know, and he was that is a different story. That is completely a different story. Right? So I just thought of because we don't tell these kinds of stories in classrooms as teachers. No, when I read all these kinds of stories, the first thing that I know that came to my mind was why such kinds of stories are missing inside mathematics classroom. So these kinds of stories, they in fact
Because
motivated me.
we feel
They
that
might motivate.
mathematics class is full of numbers.
Yeah, it is full of rigid rules, rigid
Yes.
numbers.
So we don't think of even stories exist in mathematics.
Yeah, rigid rules and algorithms, theorem proof, LHS is equal to RHS, famous. So there are a lot of such stories, okay? There are a lot of such good books in mathematics. Good novels that I mentioned now, namely Sudden Ambiguity. Is one good book which anybody can read, even not from mathematical background. Anybody can read. Such a good book. Right? So there are a lot of such books. One more book is which anybody can read without any formal mathematics background is Uncle Petros and Goldbach Conjecture. There's one more. There is one more book, one more good book which anybody can read. Anyway, I'll be going to discuss about that also. It is Uncle Petros and Goldbach Conjecture. And there are Goldbach Conjecture. Goldbach.
Bach means sir?
BACH. Goldbach Conjecture. GOLDBACH. His name is Goldbach.
Okay.
His name.
Okay.
He's a mathematician. Goldbach. Conjecture means the statement which has not been proved to be either right or wrong. So it's a conjecture. So still open.
Open to debate.
Open for proving or disproving. So there is one good aspect of conjecture. There is one good aspect of conjectures. See, that novel, it speaks of the failure of that uncle, the failure of that person Petros in proving Goldbach conjecture. Goldbach conjecture is very simple, very very simple. So you know what are even numbers are, right? 2, 4, 6, 8, 0, 2, 4, 6, 8, 10, and you know 52 is either even or not.
Even.
It's even, correct. You also know what are prime numbers.
52 is even because it has 2.
It has 2.
It is
so there is a see. This
2 is the
one
factor of that number.
Excellent. Oh, that's beautiful. That's beautiful. That's beautiful. 2 is a factor of that.
Yes,
number.
sir.
So that's why it's even. Or you can evenly divide. Even you can group it. You can divide it evenly in twos or 2 groups. So
It is an even
that's
number.
beautiful. You told it very correctly.
Absolutely.
So some people say it like this. Those who have had a very rigid algorithmic way of teaching, some students tell that it is even, sir. Why? Because it has got 2 in the last digit, unit digit place. So those which have got 2, 4, 6, 8, 0, they are even, sir. So that's the pathetic situation we are in. Right?
Sir, teachers also know only that much, sir.
No,
we have seen that many teachers.
no,
Like
maybe teachers might be knowing that they are afraid of
teaching so much to that student.
No, they are afraid to believe the students that he can imbibe, he can construct. So the very first thought that comes to a teacher on seeing some of the students is, no, he is not capable of understanding this. So 0, 2, 4, 6, 8, if it comes, it is even. Remember this. But the student struggles to remember that.
Yeah.
How many formulas, how many rules you can remember? It's full of rules. That's why when you come to class 5,
They'll sleep, sir.
they'll forget to keep commas where they should have given for
English
while
grammar?
writing numbers. No, 5,22,333. How do you write? Where do you give the comma? Or some this
3 numbers.
5, 22, 333. They forget it because how many rules they can remember? Students cannot remember. We are speaking of Goldbach conjecture, right? So Goldbach conjecture is very simple. Very simple. So can I hold it for a while?
No problem.
So Goldbach conjecture is very simple. So you know what an even number is. What an even number is. There is very good thing that you have constructed the concept very correctly, very nicely. So there are prime numbers that you already know, that you also know, right? What are prime numbers?
So according to my limited knowledge, sir, prime number is a number
can give an
which has a factor which is 1 and its number itself.
Yeah, you can give
2,
examples.
3, 5,
3,
7,
excellent,
11,
5,
13, 17,
13, 17. These are all
19,
prime numbers, right?
23,
Because,
29, 31,
yeah,
37.
you cannot divide them into
I'm
equal
a very
parts.
good student of mathematics, na, sir.
Definitely. So you cannot divide them into, you cannot group them into some smaller parts without leaving any reminder. So that they are prime numbers, right? So you take any even number greater than 4 or greater than 2. Like for example, I take 6. Can you write it as sum of two prime numbers?
2 into 3.
Sum of two prime numbers.
Okay. Sum of two prime numbers. 3 plus 3.
3 plus 3. Excellent. Very good. So how about 14? Can you write it as sum of two prime numbers?
Sum of two numbers is
two prime numbers.
7 plus 5 is 12.
7 plus 7 simply is 14. Similarly 16, how can you write 16 as sum of two prime numbers?
7 plus 7. 2 prime numbers, no?
Yeah, sum of two prime numbers.
7. 11 plus what is the number, sir?
16.
16. 11 plus 16. 11 plus 5.
Very excellent. So 11 plus 5. You can write 16 as 11 plus 5, right? So he says, GOLDBACH says, you take any even number greater than 2, it can always be written as sum of two prime numbers. So this is what GOLDBACH says.
You can take any number which is greater than 2.
Any even number greater than 2.
Okay.
It can be written as sum of two prime numbers.
Oh, beautiful.
So this is GOLDBACH's conjecture. Till today, nobody has proved this. Nobody has even disproved this till today.
Oh, so it is
Our uncle Petros was behind proving this GOLDBACH conjecture. He was a very good mathematician. He just wanted to hit a big fish. That's it. One big fish, one great fame. That's enough for my life. So that was the goal of Uncle Petros. He's not behind small fishes. He wanted to prove GOLDBACH conjecture. He was behind it, and he failed it. He failed in his endeavor. Finally. So I'll come to this story afterwards. This is the story of Uncle Petros and GOLDBACH conjecture. Okay. So see the beauty of this concept of truth. Concept of truth in mathematics. So can you suppose I say that a statement can be both true and false. What comes to your mind? Suppose I say a statement can be both true and false. What comes to your mind?
Again,
you think that I am speaking absurd.
Yeah.
I am totally absurd, right? In our bivalent logic, bivalent means there are only two choices for a statement, either true or false. Statement in the sense I am strictly speaking, they are declarative sentences. Statements means to which you can attach the truth or falsity kind of stuff, right? So there are so much of grammarian language, so which we shall not get into it for time being. Say for example, if I say sit down, this is not a statement. Stand up, this is not a statement, because I cannot attach truth or false to it. What is your name?
Vishnu
This is a
Teertha.
sentence, but you cannot attach truth or false to it. Can you say, if I say what is your name, it is true. You cannot say it is so only those for which you can attach truth or false is statement. That I am that I mean is I mean a statement to be a sentence to which you can attach true or false simply, right? So say you have natural numbers and you have even numbers. This was the homework that I had given to you in the last time. So if I ask
Natural
you
numbers and whole numbers.
whole numbers. Okay, before that,
Sir, you have water bottle, sir?
I have water bottle.
Okay,
I
very
have
far.
a bike. Shall
No
we
problem.
go walk and bring?
Yeah, we can do that also.
So we can go walk.
Do we
And
come?
meanwhile, we can speak some
Yes,
other,
yes,
some other
absolutely.
stuff
Yes,
apart
sir.
from mathematics. Or we can.
No, we can.
Thank you.
So we were speaking of, sir.
Yes. So I had given you a homework last time when we met. So
Yes,
I'll take back that homework now, right? So you have say you have bottles on
Yes,
one
sir.
side. Some number of bottles. I don't know how many. You have caps on the other side. You have bottles on one side. You
Caps
have
on the other side.
caps of bottles on the other side.
Same bottles.
Same bottles, right? So you want to close the lid. So you say lid or cap?
Cap.
Cap. Okay, fine. So you can
Indian English.
Yeah. Say without counting,
Yeah.
you should tell me whether the number of bottles and caps are same or not. on
Without
both sides.
counting.
Without counting, you should tell. Is it possible for you to tell?
If the caps belong to the same bottles, then if we
Here.
fill up the caps to that bottles. If some caps remain.
Yes, definitely. So without counting, what you're doing, you're matching cap to bottle.
Yes,
You're
yes.
pairing, right? You're pairing. If you can finish both the sides, then they are equal in number.
Yeah.
Correct? The pairing can be done on both the sides for all. Then, and the pairing is 1-to-1, right? The same cap is not for 2 bottles. The same bottle is not for 2 caps, right? Pairing is 1-to-1. If you can have pairs on both the sides completely, exhausting all the stuff, then both are equal in number, right? So let us, restrict to this concept of equality for time being. Without counting, it is possible for us to say whether the 2 groups of objects are equal in number or not, right? Now, if I ask you a very simple question, of course, a very simple question: are natural numbers more in number or even numbers more in number? Natural numbers means right?
So
1, 2, 3,
natural
4.
numbers are starting from 1 to infinity.
1 to 1, 2, 3, 4. They're counting numbers. 1, 2, 3, 4. They involve even, odd, everything. 1, 2, 3, 4, 5, 6, 1,000, 2,000, lakh.
Not including 0 is natural.
Some include 0 also. You can include 0
Okay.
also. That doesn't matter because terminologies do not matter to us anymore, right? So you can include 0 and name it whole, or you can remove. So you can add 0 to the list and say the list itself is natural. That doesn't matter to us, right? So now the question is: are natural numbers more in number or even numbers more in number? You can take 1 minute of time. Meanwhile, I'll bring the bottle.
Yes, yes. Yes, sir.
I think you have got the answer. So are natural numbers more in number? I mean, natural numbers are more in number or even numbers?
Natural number.
Why do you think natural numbers are more in number?
Sir, because when you consider one axiomatic system of frame, there are numbers 1 to 10.
Okay.
That is 10 in number.
Okay.
And they are natural.
Okay.
When you consider even among those 10 natural numbers, you consider only 2, 4, 6, 8, 10.
Okay.
5 numbers are even.
Okay. You have left odd numbers. So they are more natural numbers. They include odd numbers also. Therefore, they are more in number.
Yes,
you
yes.
say. Now you think that natural numbers on the one side are bottles. You think that even numbers are on the other side, which are caps. Okay. So, or let me reverse the okay, let me do the same thing. So bottles on one side and caps on the other side. What do I do is I take this bottle 1 and put it to cap, or sorry, this side caps and that side bottles, assume that. So I take this 1 and put it to the bottle 2. I take this cap 2, put it to the bottle 4. Number 4. Here it is 4, right? I take 3 and put it to 6. Did you see the way I am pairing the numbers? I am pairing 1 with 2, 2 with
3,
4. These are even numbers this side. 3 with 6, 4 with 8, 5 with 10, 6 with
12.
it should be 12, correct? 7 with it should be 14.
14.
Similarly, 10 it should be with
20.
20. 100 it should be with
200.
200, right? So you are pairing all the numbers on the both sides, right? You're pairing all the numbers on the both sides. Just now we spoke of equality. If you are able to pair on both the sides without leaving anything 1 to 1, then both are equal in number. So natural numbers and even numbers are equal in number, because it is possible for you to create pairing between these two without leaving anything.
Sir, I think I must understand this concept again.
Right. So say
So we can
yeah.
speak while we walk.
So just now.
I am looking good, sir. Yes, sir.
Yes. So say
The wonder of Devaraja market.
yeah. So you can turn your camera around.
Yeah,
and shoot. Yes.
Yeah.
So you understood that bottle cap analogy, right? If you're able to pair all the bottles with the caps without leaving anything, they're equal in number. Correct? The caps are left, they are more in number. The bottles are left, they are more in number. So this way, if you pair numbers or pair objects on both sides, without leaving anything on either side, they must be equal in number, right? I'm pairing 1 with 2, 2 with 4, 3 with double 6, 4 with 8. So can you cover all? Can you have pair for all the numbers here? What will be the pair for 100?
200.
200. For 101?
102.
202.
202.
202. For 1000?
2000.
2000. 1500?
3000.
3000. Right? So you for taken any number, there will be a pair here this side. Right? So you are pairing the numbers without leaving anything. The borders are fitting the caps. So natural numbers and even numbers, they are equal in number. Do you agree? Both of them are equal in number. Right? So you got the point, I think.
Yeah.
So here the caps, here the borders. Natural numbers, even numbers. You are capping, putting caps. And for every cap there is a bottle here. For every bottle there is a cap here. So when you are creating the pairs, the numbers are equal in number. Both the sets have got equal numbers. So natural numbers and even numbers, they have got equal. They're equal. They're not more in number. In the same fashion, if I ask you whether odd numbers are equal or natural numbers I mean, odd numbers are more or natural numbers are more, what will be your answer?
So both are in same number.
Both should be in the same number because you can create kind of pairing. How can you create pairing now? For odd numbers on one side, natural numbers on the other side. 1 to 1, 2 to 3, one more, 3 to 6, 5.
5. Odd number.
Odd number. You are pairing odd number. So 1 to 1, 2 to 3, 3 to 5, 4 to
7.
So observe how you are pairing. You are doubling that and lessing 1. Doubling that and lessing 1. 3 double is 6. Less 1 is 5. So you are pairing 3 to 5. 4 double is 8. Less 1 is 7. So you are pairing 4 to 7. Similarly 10.
Doubling it, 20 minus 1,
19. 10 should be paired to 19. Right? So in this way, you can exhaust all the natural numbers by pairing them with odd numbers.
By being with you, I am becoming brilliant, sir.
This is an illusion. Okay.
No, sir. This is not Maya, sir. This is not Maya, sir.
Yes, this is not my. If you assert that, then that is.
Because this is a different axiomatic system, sir.
Yes.
हाँ.
Yes. hold on.
अभी आता है. आएगा. आपको अभी हम कल मिलेंगे ना, तभी हम आपको मैथमेटिक्स सिखाएंगे. मैथमेटिक्स पता है आपको? गणित.
मैथ्स है ना? स्कूल में मैथ्स है ना?
पूरा सीख दिल्ली में.
Ask them which topic they like in school.
आप कौन से टॉपिक को पसंद करते थे? हिंदी है ना? नहीं. आप गणित में कौन सा टॉपिक को पसंद करते थे?
टॉपिक को किसमें?
मैथमेटिक्स में. मैथ्स में.
आपका HCF, do you know HCF? LCM
वो सब पता है आपको?
HCF, LCM.
पता है? 1, 2, 3 नंबर पता है.
You talk in English? Oh, super.
You also know English, sir. I mean, sir.
What is 2 4 za? 2 4 za? 4.
नहीं, 2 गुणा 4 कितना होगा?
2 गुना
4. हाँ, 2 गुना 4 8. Super.
2 into 4 is 8. सही ना? हाँ. फिर और क्या है सर?
आपका नाम क्या है?
मोहम्मद रतीश शाह.
मोहम्मद जी.
I am YATHIRAJ.
अभी आपके पास माइक नहीं है. माइक अभी अगले बार जब आएंगे ना, तो हम गणित के बारे में विस्तार से बात करने की कोशिश करेंगे. ठीक है? धन्यवाद.
तुम्हारा चैनल क्या है?
अभी हम शुरू करने वाले हैं. देख लीजिए. इधर माडवर सर.
Yes. So
I am coming to social life, sir.
Oh, super.
After
That's super. So you need to get married soon. Yeah.
No, sir.
Shall I
That
look
is
for
Maya,
any-
sir. That is really Maya, sir.
Shall I look for any?
Other market, sir.
Huh?
Other
Any girl?
Sir, in market we only find fruits, sir.
Okay,
No girls, sir.
Okay.
Yes, sir.
Yeah,
That is completely different axiomatic system, sir.
Okay. That's
Somebody
different
say
system for you.
there is existence of girls
Ah.
in the society, or
So you believe your axiom is that girls do not exist for you.
no,
That's
there is
very-
no difference of bhava.
Okay. So
We have-
there was this Russian.
I will edit this way.
Okay, you can edit. Russian system. There was this Russian. I think before World War or Second. I don't know.
I think rain is coming, sir.
There, the students of mathematics or the students of science, there's a strict rule that they should not have any girlfriends.
Fantastic, sir. There is a beautiful rule, sir.
That
And it should also happen to the other gender also.
rules, huh?
Other gender also, the same rule must apply, sir. Sir, rain is
I'm
coming, sir.
married, so I'm married, so no worries for me.
So you have to speak pro, sir.
So we can go inside the market.
Inside
Can we go
market,
inside
yes,
the market?
absolutely,
Yes.
sir.
Pass model.
Because
You
the
can
rain is
pause it
coming, we can enter into the market.
You can pause it. So this is a good place for a while.
Yes, sir. So we are inside the market.
So you can
Devaraja
show
market.
them. You can show them. I think this is.
Because the rain is coming out. In the out. My
Yeah,
English
now
is very
if-
beautiful.
Yeah. Now if I ask you the
Yes, sir.
question,
Mhm.
whether natural numbers are more in number or integers are more,
Integers are those numbers which contain negative
Negative
numbers
as well
and
as
positive numbers.
positive numbers.
Also
So,
including 0.
including 0. So this was another big
Example.
confusion for me. How do you define integers? So there was very big confusion for me. Okay, that anyway.
There are so many confusions, sir.
Yeah. So that led me go in the quest of those things. Only if you have doubts, if you have samshaya, we will go in the quest of them, right?
Yes, sir.
Else it would be completely mechanical, totally
It just
mechanical.
becomes societal imposition, sir.
Yeah, it will be totally mechanical. I guess it is for me like that, right? Okay, so if I ask you the question whether natural numbers are more in number or integers are more, you just stop for a while, and now you don't, make the mistake of hurrying. You think for a while. You think whether integers can be paired with natural numbers or not, right? In fact, yes. This was the homework I gave you last time.
Okay.
How to pair natural numbers with integers. It is possible for you to pair natural numbers with integers. So think that these are borderless natural numbers, these are caps, and you can pair them without leaving anything. It is possible by somehow or the other rule. And you just try to think for which number you pair 1 with. What is the pair for 1? What is the pair for 2? What is the pair for 3? You just try to think. You just try to think of a sketch. So in that way, you should be able to pair natural numbers with integers. It is possible.
So both are equal in number.
Both are equal in numbers. And then comes the question, rational numbers. In the sense fractions. Let me take 2 by 3. For a while, let me stick on to the same conception of rational numbers, 2 by 3 or 3 by 2, anything. So if I ask you the question, what are more in number, rational or natural numbers?
Rational
The
or
answer is rational or natural numbers. The answer is
both are
same.
equal. Both are equal in number.
It is in fact possible to create pairing between natural numbers and rational numbers. They're equal in number again. So you understood this analogy, right? How we are judging equality of numbers. Pair. 1-to-1 pair. Leave nothing on both sides. Then they'll be equal in number. So it is possible to pair.
So this happens only in a particular axiomatic system, or it happens in every axiomatic system that both are equal in number?
No, I think we have got only one axiomatic system for set theory.
In this regard.
For set theory, only one axiomatic set, or in the sense the most widely used axiomatic set theory. On the basis of that, no, I was telling you that about the book, Introduction to Mathematical Philosophy, right? So where first time when I read it, I just got astonished to see that number 1 is defined as a set of sets. Number 1 is simply a set. It's not number. Number means a set. It is a set.
Okay.
So all the axioms of set theory, axiomatic set theory, they now apply all to these numbers. right? So there is one widely accepted axiomatic set theory, which is Zermelo-Franklin set theory. Of course, there are other axiomatic set theories also, where they discard some of the axioms of Zermelo-Franklin set theory and they frame their own axiomatic set theory. So we are sticking on to Zermelo-Franklin axiomatic set theory.
Okay.
Right? That ZF, it's called ZF, ZFC. So it's training. Totally explaining. Okay, so now natural numbers and rational numbers are equal in number. Next question is, are natural numbers and irrational numbers? Can we put them pair to pair?
Irrational.
Now we get a doubt. So we need a little bit of more sophisticated tools to decide this. The answer to this question is no.
So first let us see what are natural and irrational.
Yeah.
Irrational are those which are in the root form.
Yeah, which cannot be put in the form a by b.
Okay. So
In the
root numbers
sense-
come under
Yes,
irrational.
like for example, square root of 2, square root of 3. Vaguely, if you convert that number, if you take the decimal representation of that number, for example, square root of 2 has got 1.41 something so on, decimal representation. So the decimal representation has got no pattern. It's got no pattern. Whereas the decimal representation of 1 by 3 or 1 by 7 or 2 by 5, they've all got some kind of patterns. So there's no pattern, there is no recurrence, which we call recurrence. It means some chunk do not repeat. For example, in 1 by 3, 0.33333, that 3 repeats.
Recurrent.
It is recurrence. In the same case, in the same fashion for 1 by 7, some chunk repeats. So if there is no recurrence, there is no stop.
Repetitiveness.
There is no repetitiveness in the decimal structure, or there is no stop. Like for example, 1 by 2 stops at 0.5, right? If that happens, right. So then the number would be irrational. Irrational numbers, they have got such kind of property. Okay. So root 2 is irrational. Of course, what definition I am telling is what is being taught today in the books, and not what I got to know later.
Okay.
So the definition that I got to know later through data kind is completely a different one. It is fascinating one. Now it is quite difficult for me. It's not difficult, but within this time framework, it would not be possible for us to discuss that. We can discuss it afterwards sometime later. So that is completely a different definition. For time being, let us stick on to this, right? Okay. So because the definition doesn't matter to us for time being. So we got to know of irrational and rational numbers, right? So the question was, are irrational numbers more in number or rational? Irrational, as you said, root 2, root 3, which are not perfect squares. Root 4 is a perfect square. Answer is 2. That is rational. Root 2, root 3 cube, cube root of 2, cube root of 3. Along with that, there are so many other irrational numbers also, like pi. Pi is irrational.
Pi is irrational.
Irrational. But what they have taught in schools, pi is equal to
1.2.
Pi is equal to 22 by 7.
Yeah, after division, it
It's
becomes
3.14.
some non-recurrent continuous number.
Then that is you have been taught correctly. That's it.
That
Pi.
is it.
So pi is irrational, but most
Okay.
of the
You are
students
saying,
even today in my
it is a
class.
particular constant you are saying, no, sir?
Yeah.
Okay. It is not a particular constant.
No, it is a constant. It is the ratio of the diameter of the circle. Ratio of the circumference to the diameter of the circle. The ratio, circumference means the perimeter of the circle.
Circumference of the circle is equal to 2 pi r.
Right. So you take the circumference of the circle, divide it by the diameter. For any circle, however large, however small it may be, the answer would be a constant always. The ratio remains constant always.
And that constant is pi.
That constant is pi. What we define it vaguely again. So that is pi. Right? So pi 22 by 7 is an approximate value of pi simply. So
Okay.
that's it. So 22 by 7 is not pi. So pi is not rational. Pi is irrational. Okay. So there are so many such numbers. Pi, e, so many other irrational numbers. So if I ask the question,
E is a complex number. Huh?
no, it's again one more real number. It is another constant. It's called Napier's constant.
Okay.
So that is something different.
So how is
Something
complex numbers? Sir? Iota.
different. A complex number is okay. We'll discuss it afterwards. So it is
Complex
something-
number is symbolized with I. Yeah?
I, yeah, it is square root of -1. We introduce something new object, new animal, called square root of -1, root of -1. We take it to be
Okay, square root of negative numbers.
square root of negative number. We turn that into another object, another animal, I, and use that I to introduce new kinds of numbers, what are called complex numbers, and so on, right? So we'll discuss it. We'll discuss it if time permits, right? So the thing I was asking you is whether irrational numbers are more in number or natural numbers.
Irrational numbers.
So the answer to this question is surprisingly irrationals are more in number.
Yes, sir.
Unlike these rationals, integers, even or odd, the irrationals are more in number. So how do you get to know? If you have natural numbers this side, if you have irrationals this side, you try to pair in any fashion, irrationals will be left. You try to pair in any fashion one to one, there's no way you can exhaust the irrational numbers. So something will be left out. So they are more in number, irrational numbers. So of course, automatically real numbers should also be more in number, right? Compared to natural numbers. Because they include irrational also. So they should be more in number compared to
Real
natural
numbers are rational plus irrational is equal to real.
together. So together, rational and irrational together, we call them to be real
So
numbers.
those numbers which could be expressed as p by q and which cannot be expressed as p by q, all are real numbers.
Or which have got recurring decimal representation, terminating or non-recurring, everything together you call them to be real numbers. Okay. So now the question is whether real numbers and irrational numbers have they got same are they
Real and irrational.
irrationals? Are the same in number or which one is more?
They should be same.
Yeah, that should be same, but you did a good guess. But it takes a lot of efforts
And
to answer
courage.
that question. Yes.
So what is this?
The
is
answer
my
is
homework?
yes, correct. The answer is correct. So reals and irrational numbers, they are both equal in number. And I remember that last time you told reals are more in number. And this time you have made a right guess.
This is my
Because
first
there
video
are
in
only-
English and I have not done any video previously, and these
No, last
concepts are
time
very
when we
much
met-
new to me
Oh,
and
okay.
I don't know anything about these things. Sir is a very beautiful person, but he is lying in this thing. But I am very
You can cut this,
very
you can edit
dumbest
this.
person in the mathematics arena, and I know I don't know anything in
Okay,
mathematics.
you can edit this and you can cut it off. Okay.
No. This is the reality, sir. This is the axiomatic system of Maya, and everything is real in this axiomatic system. So this is existing.
Okay, so
Like real numbers and irrational numbers, all are existing on the same plane. This truth is existing, sir.
no, it's very difficult to speak of existence.
Okay.
Existence of something. It's very difficult to speak of existence.
It is relative, sir.
Very difficult. Very difficult. At least for me, because I don't know anything about it. It's very difficult to speak of existence of something. So when do you say something exists?
Sir, then
difficult.
numbers
You must
might
define
exist, might not exist.
You must define it first. So when do you say something exists?
So numbers too, according to you, might exist or might not exist.
You know the story of Descartes, René Descartes.
Who is that
He was
person?
also a mathematician, a philosopher, a French philosopher. Most of modern philosophy, I think, was influenced by René Descartes, I think.
Modern
So,
philosophy.
have you heard of this?
Philosophy.
Yeah, Western philosophy. Have you heard of this? I think, therefore I exist. Have you heard of
think,
this
yeah,
phrase? I think, therefore
I
I
have
exist.
heard it from philosophers. Yeah, I think because of I think I exist. I exist.
I exist. Right. So it was made by René Descartes. So he was into a kind of meditation wherein he was pondering upon how do I prove that I exist. It might be a dream,
Absolutely.
right? So say what I am speaking with you. How do I prove that it's not a dream?
Absolutely. Shankara also, Acharya Shankara also
Right.
spoke about the same thing, sir. When you think of whatever you are watching is reality, it is like a dream. When you wake up of the reality, it becomes the reality.
Yeah. So how
You are
do I
living the reality when you are sleeping. That was reality when you were looking at it as a reality.
Yeah. So how do you come to conclusion that you exist? Therefore, he says whether it's a dream or whether it's not a dream, I think. So therefore, I exist.
Absolutely.
Right. So why did we come to this aspect? Because of existence. So
Existence.
existence. Speaking on existence is quite difficult for us. So let us leave it for a while. So we were speaking of the sizes of sets. correct? So
Yes.
real numbers
One
and
is also
irrational
a set.
numbers, yeah, real numbers and irrational numbers, they are equal in number. And natural numbers are fewer in number compared to irrational or real numbers, correct? But on one side they have natural, integers, rational. In fact, rational numbers include all this, right? It includes natural numbers also, because one is also a natural number. It's also a rational number. I can write it as 1 by 1, right? So therefore, on one side we have rational numbers, on the other side we have real numbers. The question is, can you have a set which has got elements, more number of elements than rational numbers, but lesser number of elements than real numbers? You can understand the question. So on one side I have rational numbers, on other side I have real numbers, right? Can I have a set which has got more number of elements compared to rationals, but less number of elements compared to real numbers? In between these two, can I have a set? What would be the answer?
Rational and real.
Between rational,
Rational and real.
can I have one set?
Irrational.
Irrationals also have got same number of elements compared to real numbers. So my question is, can you have a set in between rational and irrational such that you should have more number of elements than rational numbers, lesser number of elements than real numbers? Say here it is rational, here it is irrational. Sorry, real numbers. So suppose I have a set in between. If you are trying to pair with it, some should be left out here. Means they should have more number of elements compared to rational. Similarly, if you are trying to pair with real numbers, here you should be left with some more. Whatever the way you try to pair. So is it possible to find one such set in between these two, having more elements than rational, less elements than reals? What would be your answer? Either yes or no, right?
Yes, yes, sir.
Yes or no?
Yes or no?
It's possible, yes. Or it's not possible.
Not possible.
Right? What if I say it is both possible and impossible?
Okay.
What if I say it is both possible and impossible?
Sir, the last time.
That's the beauty.
Yeah.
That's the beauty of axiomatic system. That's the beauty of axiomatic system. So we are speaking. You rightly pointed out. We rightly brought that into our discussion about which axiomatic system we are sticking on to while discussing this. ZF axiomatic system, right? So in that axiomatic system, it is not possible to either prove this or disprove this. It is undecidable. This thing. It is not possible to prove from all these axioms of the set theory. It is also not possible to disprove this statement from all these things. So that's the beauty. So that means you can take this itself as an axiom. So if you take this as true, you'll get a system full free of contradictions or completely consistent. If you take this not true, you will still again get another system which is free of contradictions, which is perfectly fine, perfectly it works correctly. So that's the thing, right? So assuming that such a set does not exist, so that's called continuum hypothesis. That is a famous problem of mathematics. So it's continuum hypothesis. If you assume that such a thing does not exist between rationals and irrationals.
Oh, so there comes the relevance of Descartes.
How? Does not exist. Okay.
Yes.
It's existence.
Yeah.
It's something. Okay. So
No,
it does not
sir.
exist.
It is establishing
still-
analysis.
Yeah. It's still very. You rightly pointed it out. For me, it is. It brings into me. It makes me again
more.
still worried. Think more about existence and inexistence. Yeah. It does not exist. It does not exist in the sense. What do you say? It does not exist. It does not exist. Simple. You cannot find such a set. That's it. You cannot find such a set having these qualities. Right? So it's called, if you assume that, it's called continuum hypothesis. Another thing. So it says the continuum hypothesis in the sense, assuming that such a set, it is not possible for you to find such a set is consistent with all these axioms. It's not possible for you to prove that, but it does not contradict any of these axioms also. Does not go against any of these axioms also. If you take this and put it in your system, nowhere you will get a circular argument, nowhere you will get a contradiction, everything perfectly fine. So you can take this as an axiom. So this is the beauty of axiomatic system. There will always be some kind of undecidability. So Bertrand Russell, he was trying to. So
Can we walk through?
yeah,
market?
definitely. So
I
but
think the rain has stopped,
this
but droplets,
water
are
droplets
still
will be-
falling.
Yeah, they'll be falling.
ಮಳೆ ನಿಂತು ಹೋದ ಮೇಲೆ ಹನಿಯೊಂದು ಮೂಡಿದೆ. Concept of Kannada song
Hmm.
in the middle of the English conversation, which is a national level conversation about mathematics.
Well, national level. So usually what we do for national level seminars,
Yes, sir.
we'll bring one person from out of state. That would be national level.
Yes, sir. We are from Karnataka, and the audience are from other states, so it is a national level. Yeah. This is the world famous Devaraja market. And here are the flower viewers.
ನಮ್ಗೆಲ್ಲ ಹಿಡೀರಿ.
Mic ilvalla? Yes, sir.
Right.
So this is Mysore Malligi. This is very
Okay,
famous.
so geometry was axiomatized for the first time by Euclid, right?
Geometry.
Geometry.
Okay.
what
Geometry.
we are-
When we think of geometry, we just think of geometry box, sir. You are speaking of geometry of mathematics.
Yeah, geometry of mathematics. So in the same fashion,
Yes, sir.
Bertrand Russell and Whitehead, they tried to axiomatize arithmetic. There were no axioms for arithmetic.
Oh, there are also
how do you-
axioms for arithmetic.
Arithmetic, yeah. How do you prove that 1 plus 1 is 2?
Okay. So we are assuming something to be true, and
Yeah.
starting from there.
Yeah. So in fact, Bertrand Russell and Whitehead took nearly 300 odd pages to prove 1 plus 1 is 2.
Okay.
If you ask me what is the proof, I don't know. Really, I don't know how many people have touched their book, Principia Mathematica, which is more than 100 pages. I don't know how many people have completed that book. Extremely quite difficult book.
So you can go straight, sir.
Excellent, very good.
Mic ilvalla?
Jai.
ಅಪ್ಪಣ್ಣಿಂಗ ಅಣ್ಣ ಓಕೆ ತುಂಬ ಕೇಳ್ಬೇಕಾಗಿ
Yes, sir. You are speaking of?
Yeah. So, of course, that is to an extent axiomatization of set theory.
Axiomatization of set theory.
And also,
That
apart
means,
from that, it included more.
Sir?
Right. So they tried to axiomatize arithmetic. Okay.
Okay.
Arithmetic means numbers,
Yes, sir.
operations, sets, numbers, set. So all those things they tried to axiomatise it. So for them, the main goal was to build an axiomatic system where any statement regarding numbers can be proved from their axioms. In the sense, they wanted to build a complete axiomatic system. Right?
Okay.
If I make any statement, you should be able to prove or disprove that within your axiomatic system. In the sense, complete axiomatic system. So that was their target, whose Russell's and Whitehead's target. Right? So but one fine day,
So I think we can go out from here.
ಬಾಳೆಹಣ್ಣು ತಗೋಬೇಕಾ?
one fine day, a young German mathematician, I think, Kurt Gödel, he
was a young-
he in fact disillusioned them that it's not possible in whatever axiomatic system on numbers, you build any axiomatic system on numbers, there will be one statement which is undecidable,
Okay.
like
Descartes.
between two rational and irrational. There is an undecidable statement, right? We cannot say whether it is true or false. In the same fashion, so you build any
Yes, sir.
axiomatic system, there will be one undecidable statement. You cannot decide it. So it is about undecidability of that statement itself. So this was a big blow to whom?
The German
Bertrand Russell and Whitehead. They failed in their
quest.
attempt or quest to build a complete axiomatic system. Right?
So this
So-
is in the evenings of Mysuru,
Mysuru. It's
Market.
5 o'clock now.
And in the rainy weather, which is the most profound weather of Mysuru and Bangalore.
Yeah.
Yes, sir.
So I was, mentioning I had mentioned that book, Uncle Petros and Goldbach conjecture, right?
Conjecture.
So where Uncle Petros was behind this Goldbach conjecture, right? We can come this side. So Goldbach conjecture, by conjecture it means it has not yet been proved whether right or wrong.
Yes.
Correct?
Yes.
So that uncle, that Petros, was behind proving that Goldbach conjecture.
Yes.
So see, when a person is behind something, very seriously, he would be meditating about that. He would be a devotee of that problem.
Yes.
And when he gets to know that he would be unable to solve that problem, what would be his feeling?
He finds himself devastated.
Yeah, devastated, disheartened completely, totally, right? That was what happens to Petros. And finally, he puts the blame on Gödel.
Okay.
So I left. So he wants some excuse for leaving this problem, right? He was a very great mathematician, and people would be expecting that such a great mathematician who is working on this Goldbach conjecture would definitely prove Goldbach conjecture. If he doesn't prove Goldbach conjecture, what would people do? They would simply mock at him. So he wants some excuse.
Wasted his life on.
Yeah, completely. So he wants some excuse, right? He puts the blame on Gödel. Gödel says that something is undecidable. There will be something undecidable. So this might be undecidable. So I don't do it anymore. This is the story of Petros, Uncle Petros. So you can that's one fine good book, a good novel. So anybody with such a formal mathematics is not required to read that novel, right? So this is all regarding this is axiomatic.
This book is like one of my geography teachers used to say about a story where a geographer wrote a novel exploring about the earthquakes.
Okay.
There would be an earthquake which would be coming out on the ground, and so 2-3 children try to explore what is beneath the earth and enter that volcano.
Okay.
It was not earthquake. It was a volcano.
Okay.
So they enter into a volcano.
Into the center of Earth.
Center of Earth.
Yeah. There's a movie also.
I don't know what the movie is, but I think it was based on a novel.
Yeah, it's based on.
Which
into the center of Earth.
One of my geography teachers used to speak of.
Yeah.
And the novel you said, the book you were
Uncle
referring
Petros
to,
and Goldbach conjecture
is also similar to that.
Yeah. So
They don't require formal introduction to mathematics.
in fact, in that book, that uncle Petros, it starts with present scenario, present situation,
Okay.
where the uncle lives separately from his brothers, because they would have thought they were having the impression on him that he is a waste fellow, because he wasted all his time on something Goldbach conjecture, which otherwise he could have done something very beautiful mathematics. So they separated him. So the story starts from there, and one of the kid in that family, had a serious speculation on that uncle. He didn't believe his parents.
Okay.
This Uncle Petros seemed to be an interesting character to him, that kid. So he went in search of his history, his past, everything, and he got to know that his uncle was a good mathematician before. And then so he says that he then goes to his uncle and says, I also want to do mathematics, uncle. And then his uncle says, if you want to do mathematics, you should be very serious. So I'll give you a test. I'll give you a problem. You go back and try to solve. If you can solve it within 3 months, then you go for mathematics.
As
Or
an
else you should
option of
leave
your
mathematics.
life.
As an option of your life. Or else you should leave mathematics, because you will not be so much serious. And he gives this problem. He does not tell what it is. He simply gives this problem. Show that any prime number, any even number greater than 2 is sum of 2 prime numbers.
1 second, sir.
Show that any even number greater than 2 is sum of 2 prime numbers.
Beautiful.
It is Goldbach conjecture.
Yes.
Nobody has proved it. He has given that to this kid. And he says, if you solve this in 3 months, you can go for mathematics. Else you do not go for mathematics. And the kid goes and sits for months together, 3 months. He will not get the answer. Nobody has got the answer. This big giant himself has not got the answer. How this kid would get the answer? He comes back and says, so sorry uncle, I have not got the answer. So I will not go for mathematics, I will go for something else. and then go for economic and something else. And then while pursuing his higher education in economics, he gets in contact with one of his friends who is into mathematics. And he asks that person whether he could solve this problem, and he poses that problem to his friend. His friend says, "Man, this is Goldbach conjecture. Nobody could solve this. Nobody can solve it."
Till then, nobody could find out that it was a conjecture.
Yeah, it was a conjecture. No. That kid had not. That kid had not discovered that it was a conjecture. The uncle knew. Uncle wanted to deviate this kid from getting into mathematics, so he deviated that guy. And that kid became very angry, and he came back to his uncle and he fights with his uncle like anything. Oh, you cheated me. You gave some problem which is impossible to solve. So the story goes on like this. So then all the efforts of the uncle and how he puts the blame on Kurt Gödel for undecidability. So everything goes like this. So this is something very beautiful nature of mathematics. Like the truth changes as you change your system. And there will be some statements which cannot be either true, which can neither be true or false. You see, what we are speaking completely is from the point of view of bivalent logic. Bivalent logic, as I said earlier, has got only two options, true or false only. There are some systems where trivalent logic also works. There are three states of truths: true, false, in between. In fact, the Buddhist way of logical system was this trivalent logic. There was something in between what is called madhyamika. There are three states of truth. One is truth, other one is false, other one is madhyamika. Maybe or may not be. I don't know what it is. It is called madhyamika. So there are multivalent logic. More states of truth. It is totally for us totally, it is at this point of time very difficult to imagine how can there be more states of truth. It should be either true or false, right? Now comes this point. So it is in our hand to give the value of truth to a state.
Yes.
Now if you ask me what is truth, I say truth. I say that a statement is true
if I believe it is true.
If I believe that it is true, or it can be derived from my beliefs to be true based on certain logical rules. That's it.
Sir, but don't you think there is an absolute truth that exists in nature?
This is a speculation of many, but truth is always relative, right? For me, truth is always relative. There's no absolute. I have a very, very good counter attack on this.
Okay.
If you say there's no, so you make the statement, there's no absolute truth.
Okay.
You make that statement now.
There is no absolute truth,
including what you told now.
Okay.
This is my very interesting counter attack on this. Or you say there is absolute truth.
Sir, there is absolute truth.
Oh, you say there is absolute truth. What is that?
Sir,
how do you know that it is absolute?
Because it exists.
So that there comes a lot of problems now. Existential problems, existentialism. So how do you define existing, or when you say something exists, or what is that? You should at least try to pinpoint what
Sir,
is, or you should try to prove that such a thing exists. So if we say God exists, is absolute.
Okay. See, because we cannot show the existence or non-existence of God.
Okay.
We can debate on that issue.
Right. But how do you know that it is absolute truth? What do you mean by absolute?
If a law is made for the banning of drugs,
right,
the law is true.
Okay.
Because it is existing.
Law is true. Okay.
In that sense, truth is not relative, truth is absolute. Because it is existing. Law is existing. Law is made.
So I think we are getting confused with true, false, right, wrong.
Okay.
True, false, right, wrong are completely different concepts, I guess. We'll get back to the same issue. So true, false is different from right, wrong, I think. Right, wrong is simply verifying if I am just moving in the path or if I'm in alignment with already made rules. If I'm not in alignment with already made rules, then I'm wrong. For example, right, wrong. Is it right to hit you?
Okay.
If I say, I ask this kind of question, is it right to hit you? Is it true to hit you? I'll not ask this kind of question, right? For this, because it is something related to getting in alignment with already existing rules or not. So if we are behaving or if we are working in alignment with already existing rules or not. So we can only attach right or wrong to that kind of sentences. Truth is different from right or wrong.
So what is truth according to you, sir?
Already I said. So a statement is, for me, a statement is true in bivalent logic. For me, a statement is true if I take it to be an axiom, or if I can prove from my logical rules that it is to be true from my axioms.
Sir, this is a light lamp
Yeah.
which is existing. It is a street light.
So please don't
Which-
ask me that question. It is totally
Street light is existing here.
Yes. It
So
is
this
true.
existence.
It is true. It is true that so can I say that it is correct that street light exists? I cannot
if it
say.
is true, it is correct.
No.
Like, sir, if
It is correct to say that street light
it is
exists.
true.
It is correct to say that the street light exists. But it is correct that street light exists? No. It is true that street light exists. It is correct to say that street light exists.
Sir, it is just the play of words, sir. Whether we are addressing an issue as a true
No.
or
No. I think right or wrong is totally correct or not correct is totally with respect to procedural way of is totally related to doing the things as per the rules. Right or wrong, correct or not correct, right or false, true or false is totally for there is a status of a statement, status of some statement. I think we can debate on it, but don't ask me how do you prove that the street light exists. Don't ask me that. It is totally difficult for me to prove
this
that
is the very same street light
speaking
which is very profound now.
how do you say this? Don't ask me. It is extremely. I'm saying that it exists, so it exists.
It is existing.
I believe that it exists.
It is
So it is
existing.
true that street light exists.
Yes, sir.
It is my axiom now. This street light exists.
Huh.
If you ask me now whether street light exists, I don't know. So there is what I'm saying is there is a difference between true, false, right, wrong. Right, wrong is related to doing things.
Sir, when true or false will lead to right or wrong will lead to true or false.
Definitely.
If A is equal to B and B is equal to C, then A can be equated to C.
Definitely. That is right in doing that procedure. And it is true that A is equal to C, finally. It is
That means-
right in coming to the conclusion that A is equal to C. And it is true.
That means true can be equated, rightness can be equated to truthfulness.
No, from right thing, you can go to truth.
Yeah.
From doing things rightly, you can go to truth.
Okay.
What I perceive. From doing my argument rightly, I can go to truth.
So, when there is a debate of the existence of God, some might have felt it, some might not have felt it.
Okay.
So, for them, they are living the absoluteness. For them, truth is absolute.
For them?
Truth is absolute.
No, that's what. That is very difficult to, I'm a very layman in this area of philosophy, or philosophy of God, or philosophy of, really very layman when it comes to this kind of discussion that you must define me first what is absolute. Unless and until I cannot, discuss further. You must tell me what is absolute. I have told you what do you mean by relative. Relative means as you change the axiomatic system, your truth changes.
Yeah.
In that sense, it is relative for me.
Huh.
What do you mean by absolute in? That means that truth
Absoluteness
remains the same
in
in
the
all
sense-
axiomatic systems.
Yeah.
How do you know that?
That is what, sir.
How do you know that?
Sir,
For proving that, you need one more axiomatic system, right?
Sir, on papers, we require something, some mechanism to prove whether the truth is existing or not.
Right. So
But,
this is the current.
Male bantu. Rain is coming.
Yeah. So this is can go from that.
Yes, sir.
So this is the current debate, current complaint about mathematics, that mathematics is so much of axiomatized that it is totally has been barred from real life experiences. So real life experience simply says God exists, but mathematics asks me to prove it.
Yes.
So this is what the complaint about mathematics.
So why do you think there is a conflict between science and spirituality in modern day times?
I am not the right person because I am a layman, as I already told. I am a.
Sir, I think you must have been the diplomat of this country.
Huh?
I think you must have been the diplomat of this country, sir.
Why?
You can navigate through situations
See,
diplomatically.
I am a very ordinary guy living in Mysore and working in a small college like Sharma.
Sir, it is
I
a
just want to
very
live
great
life
institution,
and
sir.
Yes, of course, it is a great institution. I want to. I'm ordinary. Okay. Yeah.
And were there any concepts that we left for our present today's mathematics session, sir?
Maybe we can, if we feel that we have left something, we can discuss it further in some other sessions.
For now,
Like we have left complex numbers. What are complex numbers? And there's one more beautiful logic. Right? Now see, much of the mathematics, many of the concepts of mathematics, in fact, they develop from real life experiences. For example, one of the very big theories in mathematics is field theory. Field or Galois theory. Field theory.
mathematics, sir?
In mathematics, field theory or Galois theory. It's again about sets. Okay.
Okay.
One of the sophisticated theories in mathematics, field theory.
Okay.
Now, it originated from a very simple, realistic problem of Greeks. So I don't tell it realistic, but a very simple problem posed by Greeks or I think Egyptians. I think very way back it was thought by Egyptians. I think I don't know. So the problem was this. What was the problem? I have one cube. The sides are, say, for example, for our reference, I take it to be 1 centimeter. 1 centimeter, 1 centimeter, 1 centimeter. Every side it is 1 centimeter cube. See, I want you to construct another cube which holds double the volume of this.
Okay.
Say I can fill in this 1 centimeter cube of water. Correct? Volume of this is 1 centimeter cube, means I can put 1 centimeter cube of water inside this. Correct? I want to construct you another cube of double the volume. That means 2 centimeter cube volume. And I will not give you any measuring scale.
Okay.
I will only give you compass and a stick having no measurement marks.
Okay.
Is it possible for you to construct that? All you need to do is to simply construct one side. Then you can copy it, right? Copy it and construct the bigger cube. So, what is the side one cube? Sorry, what is the side of the bigger cube? It is cube root of 2. Correct? Okay. Volume should be 2 centimeter cube. So, side should be cube root of 2. Is it possible for you to construct such a cube? I have given only compass. Sorry, yeah, compass and
The stick.
a straight stick, simply without any measurement. This is one of the oldest problems faced by, I think, Egyptians or Greeks. The answer to this question is
Very beautiful situation here in Mysuru.
yeah. We can go inside and
Okay.
the answer to this question is no, it's not possible.
Oh.
It's not possible simply to construct by compass and stick.
Why do they ask only such problems which cannot be solved, sir?
No, it is not even a realistic problem, in fact, right? If you give me a measurement scale, you can easily create an approximate cube to the greatest approximity as possible, to an approximation as pleased as possible, right? So, but this is a conceptual question which is framed by Greeks or Egypt. Many of bigger Mathematical theories, they have got their origin in such problems, older problems. So field theory, for example. Answers this question. Field theory answers this question, that is impossible only with compass and to create cube root of 2. No, it's not possible. But you can create square root of 2 only with compass and stick. You can create square root of 2. So I like this way of teaching, that you have a goal. Goal in the sense, it may be a problem. We are trying to address that problem. To address that problem, we are trying to learn all these things. Right?
So
and there comes sin theta, cos theta, everything.
okay.
So there should be a problem, bigger problem. Only the main challenge for the teacher is to make students understand that problem. If I understand that problem, I will now have a cause for studying this. Right? And I try in the pursuit of that problem, solution to that problem, I study these concepts.
So the conversation we started to make that child think of most possible ways of strategies to solve a problem comes in aid to this question of life.
Yeah,
To
definitely.
give a purpose to that life.
Yeah. Whoa.
Huh.
To
So-
give. Yeah.
In music, sir, you can speak.
No, you complete.
In music, there is a concept. Once a Kalavida grows or an artist grows, Guru tells him to take up a raga and explore it for the life.
Okay.
There are ragas concept in music, classical
right.
music. So they tell him, or they themselves, as they mature, they take up a raga to explore for the rest of the life, which they will be singing so beautifully,
Okay.
which might be
But
incomparable.
how do they teach music? Why most of the students, most of the people cannot get the skill of singing? Do you believe that everyone is capable of singing?
Sir, it is just like mathematics, sir. Everybody cannot do mathematics.
No, I never tell that. I tell that everybody is capable of doing mathematics.
Okay.
I tell that everyone is capable of doing mathematics. So see,
In that way,
see. One simple example is you have explored one bigger problem for yourself,
yes, sir.
right? Which are more in number, natural numbers or even numbers?
Both are
Same. That you have explored.
yeah.
Anybody can learn any bigger concept of mathematics if given a proper
Guidance.
environment.
Yes, yes.
Proper environment to think, proper environment to create analogies for themselves. Right? So,
Sir,
in
but
the same fashion, isn't it possible for anybody to tune up their tone? Or isn't it possible? Or does it depend on tune, the voice?
sir, it is like even though you can give environment of mathematics, which is so beautiful in its existence from the very childhood, only few will opt for mathematics.
No, that is the current scenario. That is the current scenario. We have not. Have we ever
So we can
tested
sit
that?
there, sir.
Yeah, have we ever tested that? Creating proper. No, I agree.
Yes, sir.
I agree that, for example, even if you give me proper environment,
Yes, sir.
for thinking in mathematics, of course, my interest would be on something different. It might be on something different because of my background or something else. I might be interested more in singing, and I might leave mathematics for singing. Right, so I might leave mathematics because I want to pursue singing, or I want to pursue physics, or I want to pursue something else. Because somebody else may see that mathematics is so rigid because of its axiomatic structure. So I don't want to pursue mathematics. I want to pursue physics because it is so lenient. No, you can alter your hypothesis any way you want, however you want, and you can test.
Yes, sir.
You're less rigid. You're more flexible in physics. So somebody may go for physics because of intrinsic, differences of opinion with mathematics, right? It all depends on how your background or your. But I think everybody is capable of constructing knowledge of the concepts in mathematics. That I believe.
Sir, it is still, I think, individual yearning to that subject, and the passion of the Janma Samskara. So many
I don't know.
might be. See, sorry, the belief system might be different.
Different, yes.
But
Axiomatic
the
systems are
existence we have to accept, sir.
that
Like,
that you have accepted. That you have accepted. I don't have any problem with that because
Yeah.
your system is different from mine, and so I will not argue with saying that it is not right, it is not correct, or it is not true.
Because it is fundamentally a different approach of looking at truth.
Yes. So I'll not argue with that because
It's a beautiful
yes,
here, sir.
scene. See, I'm very just fascinated by this axiomatic system. I'm still studying. I'm still studying the philosophies. I am very much interested in there is one philosopher. It's called Ludwig Wittgenstein. His philosophy is entirely different. Of course, I'm unable to catch them, but still I'm trying to learn. I'm still trying to learn, and sometimes in future, as you said the other day, I might feel that my way of looking at truth might be wrong. I don't know.
Then
And then
you
I might accept your point
axiomatic
of view.
system
Then,
of
yeah.
theory.
I don't know.
Then I think
Times of the future
there
I
would just be a change of axiomatic system.
Or I don't know. I might shift my thought processes completely away from this axiomatic system itself. I don't know. Currently, for time being, I am sticking on to this mode of looking at truth through axiomatic systems. I don't know. I might change this, change, or I might not change. I might stick on to this throughout my life. I don't know.
Let the time decide.
Yeah, the time decides. Then I might believe that there might be janma karmas. I don't know.
Like, sir, there are so many doubts, sir. Once you start questioning
Yeah.
the existence of life and so many things, when you start noticing a very small child from his very birth, he starts singing like a maestro.
Right.
So how
are
can you
some
define that fact?
Maybe that might be because of music. Mostly depends on your physiology. I mean in the sense your
No, sir, the physiology is
structure
just
or
just one
structure of
part of it,
larynx
sir.
or
Like the Shruti Gnana or a
Right.
Tala Gnana.
right.
It just comes from samskara.
No. Oh, right. Then I must say that anybody is able to learn music.
No,
I must say that then. It's not just about your physiology, then I'll definitely say that anybody will be able to learn music.
how is that possible, sir?
I say that because I believe that.
Okay.
I believe that everybody will be able to learn anything. Of course, I may not be able to learn how to fly using only my hands or legs, but if some group of people are able to learn something, definitely I would be able to learn that thing also. So that's my belief currently. And if I think that I'm not up to the mark in that field, it might be because of my past experiences. My past experiences might not be in a way to make me learn that thing. So that might be the reason for me.
So in our society, there was always a welcoming nature of
Suppose you have this,
accepting the Charvaka speaking in front of the Shankara Sadvaita Pitha. That is contrasting thoughts have always existed in our society from the very ancient times.
Yes.
So we'll just accommodate these two, sir.
So you're just accommodating.
Yeah.
Huh? You're just accommodating.
Because the other thought is also just accommodating the other thing.
Oh, right. So we are co-living,
Yeah.
right? Coexisting.
Yes, sir.
We're coexisting, co-living.
So in this world famous beautiful Devaraja market of Mysuru, I think for today we'll end the conversation of
Yes.
exploring mathematics, the jignasa of Ganita, Atato Ganita Jignasa, the sutra that we started
Brahma
with,
Jignasa.
with the first sutra of the Brahma Sutras, which is the Atato Brahma Jignasa.
So that is again something very beautiful. Athato Brahma Jignasa. There are two words in the beginning, right? Atha Ataha means then therefore. An inquiry into the Brahman. Why then? Why therefore? So there's a question.
So
So
different.
why he has written then and therefore?
Mhm.
And there itself, the interpretation of Shankara, Ramanuja, and Madhva, they all three get separated from the interpretation of the first shloka of Brahma Sutra itself, right? Correct? If I am not wrong.
There are four to five different chapters of the Brahma Sutras, sir.
Yeah.
So every sutra might be interpreted differently
Correct,
from
correct.
Madhva's
Definitely.
perspective, Dvaita's perspective, or the Advaita. So the
Definitely.
first sutra is starting of the Brahma Sutras. No?
So
we
there,
can
there
say-
itself they get separated, all the three.
Yeah.
Their sutras. Shankara,
That is the beauty.
Shankaracharya's qualifications for Brahma Jignasa is, as you said, is not possible for all. Right? So you are saying, so nobody, all cannot learn mathematics, or all cannot learn
I have
music.
I have never said
No,
that.
no.
Sir. I have to clarify because see, I have never said that nobody can or everybody cannot learn.
Ah, yes.
I have just told that it takes some time. It might take a few
Right.
years, or it might take
Right.
janmas of samskara to come to that point. You might not believe at this point of time there is existence of janmas.
Okay.
That is a different issue altogether.
Yes.
But it takes
So let me
the
take
amount of
this
time.
Janma itself.
Amount of time I am
it
speaking
might
of.
vary. Yes, okay, right, fine. But the Shankara, if I'm not wrong, Shankaracharya's, Sri Shankaracharya's eligibility for Brahma Jignasa is quite difficult, I guess.
Okay.
Because you should have
Vivek
so and
and
so
Vairagya.
qualifications
No.
to get into Brahma Jignasa.
Okay.
Like you should be nirmohi, or you should be free from all lust, you should be free from so and so to get into Brahma Jignasa. But Ramanujacharya, he makes it less flexible and practical, little bit practical. How? In the sense, like, if I'm not wrong, again, because all these things I just have read. I am not a Pandita of Samskrita. Right? Okay. So what Ramanujacharya says, then therefore means you have done so much of stuffs already, karma, and now you are feeling that that's not enough. So therefore you are getting into Brahma Jignasa. So this is what Ramanujacharya says. So you have done so many, all of the things, what is called, was suggested in Karma Kandas, rituals, and you have felt that you need something more. So therefore you are getting into Brahma Jignasa. Then Madhvacharyas might be something different. I don't know what it is. So there, in the first very shloka of itself, there are three. I mean, in that way, these things again, they seem to be beautiful to me. In fact, the first shloka, I mean, I started my thesis with this shloka itself, Brahma Jignasa.
Okay.
Then therefore an inquiry into the Brahman, because I had my own reasons for then and therefore. So
it is a beautiful coincidence that we started with this vlog too with the same Brahma Sutra with which you started your thesis.
yes.
That to Brahma
I
Jignasa.
didn't. I mean, I just wrote that. Then therefore an inquiry into the Brahman of this thesis.
It's a beautiful endeavor of trying to look at what is the reality of existence, and I think every different thought must exist in the society
Definitely coexist.
because
There should be
people have
debates,
different
there should be
frequencies of lives, and according to their frequency they can tune into some philosophy and they can find solace in that philosophy.
Or do we need philosophy? Do we need a philosophy?
Another debatable question.
Yeah.
I
That
think-
might be again one more philosophy. Right? So do we need a philosophy? Is a philosophy? Maybe. I don't know. Yeah.
So we'll again try to explore so many mathematical concepts in the upcoming series of mathematics that we started from this world famous Devaraja market
Yes.
in the Mysuru city.
So has Nagbhushan sir taught you English?
Nagbhushan sir, I have not heard of him.
You have not heard of. Because he used to make this phrase always, world famous Mysore.
Okay, because
Oh, sorry, not world famous Mysore, world famous college. or college or something. No, not Nagbhushan, sir. I think it is some different person in our PUC who used to make this statement. World famous in Mysore, or something like world famous in Mysore.
Violets flower simultaneously, sir.
Huh?
Violets flower simultaneously.
Yes, correct. So world famous in Mysore. Yes. Okay, so thank you.
Thank you so much for.
So this is a learning for me, definitely.
This
If
is
some people give any comments, please let me know. That will at least try to make me think in different direction. Yes.
This gradual process will make us think differently of life.
Yes.
Thank you so much for being our guest for today. Of
I'm a
trying to
Jignasi
explore.
now. I'm also a
Yeah.
Jignasi. Yeah.
And trying to make so many people of the society become and join this sect of Jignasus,
Oh.
Jignasu Shishus.
I'm also
Let them
Jignasi.
become Jignasada Shishugulu. That means the Shishus of Jignasa. That is the children of Jignasa. That this cult or a group of people become more and more in number. And thank you so much for exploring so many beautiful and thought-provoking and very much difficult concepts of mathematics to one of the dumbest in the mathematics. Thank you so much.
Thank you.
Thank you so
Thank you
much.
very much. Thank you.